I have no idea if this is gonna work. Oh, it is working. Sweet. Well, actually, I don't know. I don't think the view counter works though. I think that's broken. Oh well. All right. Actually, maybe it is working. It's kind of surprising when things just work after like several months of not using it. Seems like MSAA is broken. Segmentation fault, what? Where? Oh, here. Okay, that's certainly not working. Interesting. It's like drawing them at the wrong spot. Well, let me try this. Yeah, there we go. Yeah, that's true. I'm back. After a while. I don't think I've streamed since like March. or February, I don't remember. It's been a while. Oh, that's sweet. Yes, I'm still, I have my little shader language I'm going to work on a little bit today too, which is exciting. But yeah, I'm still working on the, the same stuff pretty much as I was before. Yeah, that's awesome. Is it like a C-like language? I assume. I've never written like a proper compiler yet, like a proper language. Like I have my little shader language in this project that I do have a compiler for that like builds a syntax tree and then generates output, but my output is just other shader code. So I don't actually have to do like any extreme error checking or stuff like that. So it's kind of like it's more of a translator than the compiler, I guess. Yeah, that's sweet. I'm sure it makes it really portable too, using WebAssembly. Because then you can just run that basically anywhere you have like a browser that that supports WebAssembly. I'm gonna need to center this. How do I align text? I don't remember. It's like some of my code in here. Yeah, sure, if you have a link for it. Oh, I'll check it out. It sounds awesome. Yeah, let me see if I can click that link. I have this weird setup with my live stream where I have like a second computer that does the actual streaming. So 1 second, let me grab that link. Copy. Oh shit. Bear with me. I'm excited to try it. You're hyping it up. 1 second. Bear with me. This computer's really slow. I have it's a crappy computer that runs this live stream. It's like stuck opening Firefox right now. Here, 1 second. I'll pull it up. All right, I've got it. I've got the sauce. All right, here we go. Nice. Nice. Isn't it so satisfying when stuff just works too? Yeah, I really have to learn. I have to learn web development stuff because I don't know like anything about the web. I want to get WebAssembly support for my engine so I can like have a web target. But then like, yeah, it gets complicated with the graphics APIs. It's like, well, then I need to use like web GPU or WebGL. And it's just a lot of work and I don't have time. Oh, that's cool. Actually, I want to see this now. Hold on, let me read through this. Oh, there's a ray tracer. Whoa. Can you move the camera? No. Text rasterization? Whoa. What is happening here? Is this like, did you like hard code the, what is happening here? What is this? Oh, the video's gone. Oh, shit. 1 second. There we go. It should be back. I don't know how long it's been gone. I was looking at Snake. And then I saw the, the ray tracer looking good. This is a software renderer. That's really cool, actually. Sparrow. It's pretty fast too. That like went pretty quick. Fractals. Oh, falling sand. This one gets my interest. I have a pretty good CPU. So that's probably what helped, the Fibonacci. Yeah, 1.3 seconds. I'm gonna be like embarrassing my web development. How do you open DevTools? Is it inspect? I'm not used to. Here, maybe if I open this in Chrome. I think I'm more used to the way Chrome does it. Where's the DevTools tab? I remember this at one point. Sources. Where is run? Oh yeah, obviously I have to run the program. I have no idea what I'm looking at, to be honest. Like one of these. Yeah. Interesting. Yeah, this is cool. I'm inspired. I like how it has a UI too. You can just like edit this, I assume. Hold on, let me add some stuff to this. The update loop. What's the update? Let's see. Game draw. Here we go. Here we go. I found the checkerboard pattern. I'm going for straight like eye. Destroy your eyes with an intense classic checkerboard pattern. Snake.draw. Where's the snake? Is this the snake? Yeah, this is the snake. Trying to see where you're doing the animation for like the smooth movement, unless it just is smooth. Yeah, that's fine. Yeah, this is cool. Oh yeah, I see ticks per second. I want to see the ray tracer. Yeah, here we go. I'm gonna get rid of shadows. Nice. Yeah, you should. All right, sweet. Yeah, at least on the web, it's like working with graphics APIs is pretty simple because you have like two options. You either use like OpenGL ES, I think, WebGL, and then I think the new one is WebGPU, I suppose. So like, but you can just like pick one, and it's just like easy. Whereas when you program for like desktop, it's like, I mean, you can just use OpenGL everywhere pretty much, unless you want to do Mac. Then you're stuck with like an old version of OpenGL, and then yeah, it's a mess. It's a mess. Okay, I gotta remember how to center this text. I'm working on my renderer right now, actually. Been working on it for like a week. I've only started working on the engine again over the last couple weeks. I kind of didn't do anything over the entire summer, unfortunately. I was like pretty busy with stuff. Usually how it goes. I like start to get back into projects in fall and winter, and then fade away in the spring and summer. I'm forgetting how some of my code works, so I don't remember how to center text in my engine. How do I center this? Oh, I think I have to manually do it. Oh, that's horrible. All right. I remembered I don't have a way of centering text. I have to like manually calculate the text dimensions, which is not ideal. Let's see. What should I store this as? Yeah, here we go. Got some nice text. That red text is hard to read though. Yeah, that's pretty cool. One thing I want to do with this engine is like, I mean, I kind of have like a bunch of goals for this engine, but like one of the projects I want to work on is a 3D renderer. So like just rendering levels and stuff. And I'll need like a map editor to actually like make the levels. So I want to like make the editor in my engine for my engine. So it's like entirely self-contained. I think that'd be kind of fun. Yeah, I'm working on this text right up here. If you can't tell. Oh yeah, I haven't even shown off the snow particles. I can crank these up really high. It's probably hard to see on the stream because it turns into like like confetti compression, but maybe it shows up. We'll see. Yeah, like I was saying, I've just been working on the graphics code a lot, so I'm like testing a bunch of stuff out in this little project here. Yeah, it kind of does. And yeah, it's like a really basic level too. Nothing, nothing to write home about. But yeah, I implemented instanced rendering to the engine, so I can do like a mass number of particles just really fast. Yeah, I'm not sure yet. Yeah. Yeah, deferred has its pros and cons, which is like the annoying thing about it. It's like really easy to write a deferred renderer because you can just like create a G buffer and then kind of shade stuff, and I don't know, I think it's like easier to reason about how a deferred renderer works. But it gets complicated when you want to do like transparent materials, because then you need like a second pass for the transparents only. And you still need to like light the transparent stuff, which means you're like implementing both the deferred renderer and a forward renderer at the same time. If you have like a deferred renderer that supports transparent materials. So then there's like other rendering techniques out there, like clustered forward, or forward plus is what they used to call it at my old job, forward plus, which is just a forward renderer, but it like bins the lights into like I forget what the terminology they use for it is, but they like bin the lights, so like only the fragments that actually like are affected by the light calculate the light. But you need like a pass before that to like calculate this clustered light data structure for the fragment shader to actually sample from, and it gets complicated as well. So, but I mean, with the engine, like I'm just writing the engine in a very general purpose way right now, so it's like it's kind of up to the game that I make in the engine which sort of renderer I would use. Yeah, I don't know actually. All right, I need to this doesn't need to be so big. Actually, let's see. So I'm going to create a little lambda function. Yeah, I'm a big fan of z being the up vector, up axis. I hate positive y being the up. It just kills me every time I see it. It doesn't make sense to me because it's like when you render in 2D, 2 dimensions, x is to the right, y is down, right? So if you're going to become 3-dimensional, it's like your world needs a new vector, new axis. Z is the next one up. But it's like, is it because my mind intuits the XY plane is like a top-down, it's like a top-down view versus like a side view platformer. So I've just always seen it like that. Because it used to annoy me with Minecraft. It's like you'd like do stuff in Minecraft and then you have to like do some mental gymnastics to figure out what your position is, because it's Z is like one of the I don't know, horizontal plane dimensions. All right, what am I doing? Here we go. Got some nice labels now. I added some sphere generation code to my engine here. I have 2 different types of spheres. You can see the icosphere. I can decrease the resolution here. Test sphere. So the icosphere uses in, what's it called? I don't even remember the terminology. It's like an icosahedron or something. Let me see. Icosahedron. And it subdivides it into a sphere. So you get these like nice triangles. Let's see. Probably impossible to see, but you get these nice even distribution of equal sized triangles on the icosphere. But the problem with that is that when you, oh, that's not what I meant. What happened to my wireframe? when you want to UV map it, you get these ugly seams along the border where it wraps from like UV1 back to 0. And that's pretty ugly. So then I added the UV sphere, or the lat long sphere, I've seen it called, which has the triangles converge at the pole, so you don't have that ugly UV seam, but you do have it if you look straight up, because it distorts the UV size. And the reason I added these spheres is because I wanted to add the skybox, or the sky sphere. And I was like, well, it'd be kind of nice to just have a utility function to generate the vertices for a sphere. So I went down that whole foray the other day, which was really fun. I say that sarcastically. But what's cool is I can subdivide it in real time. So I can put this down to like a box. Oh, it's clamped at 3, that's right. It's like that real-time LOD here. And then I use those spheres for the instanced rendering test, which is what's happening here. So every one of these little tiny spheres is using an instance draw call, and then I can frustum call it. So that works, which is great. But now I need to make some changes to the way I'm handling the textures for the engine, which I'm going to work on in a little bit here. What I'm finding is like the more I add to the engine in terms of like I guess the modern graphics features, it's like the more I keep changing the way I want to abstract how like the API actually works and how resources are handled by like the engine versus by a game. So like what I have right now, which I want to change this because I don't like this anymore. It's like if I have something that renders, like if I go to this little test example and find where I'm drawing the sphere, let's see. Draw. I need to get better at navigating my code here. Here we go. Here's an example. So like right here are my draw calls to these spheres. And this is just like a little class I made at the top of the function. So a sphere basically just has, in this little test scenario, it has a vertex buffer and an index buffer. And draw just calls to like, eventually makes its way back to like DirectX 11, like draw function. But the way I bind the texture is I have this really sort of hideous line here to get the texture and then actually bind it to like the texture slot so the shader can use it. And part of this is this material thing. So I added a material, maybe I can make this a bit bigger. I added a material concept to the engine, I guess, where you can then get like the color texture if there is one, or I can do like the normal texture. Because I had this idea that in the engine itself, I would support the concept of like materials as like a group of textures. Which I might still do, but it's like, I don't know if I should have that as part of the engine or if it should be like a feature that I add as part of a game that actually uses materials, if that makes sense. Because I have the material asset, which I then get the texture like ID from, but I don't actually have a way of just getting a texture directly. So like in order to create a texture, like right now, I have to have this like here's the sky texture. I have to create this material thing here and then specify that it has a color texture and it's at this path. And then the build system will like find that and get the texture data and you know, get it in an accessible format for the game when it runs. But I don't have a way of just doing that for like a texture. So I need to add that because it's kind of crazy that I did the material before I did the texture in hindsight. Because like I should be able to just do like texture. And there's like some code here that like looks like it would work. Like I should be able to just do this. But I can't do that right now. So I need to add that. Which is gonna be fun. So yeah, I'm gonna do that right now actually. Call it text sky. I don't need that. So like the texture might just have like a path, which is like the path to the texture, and then do like MIPS, generates MIPS. So I basically just need to make the build tool know that these texture files exist and then what to do with them when it finds one. So build So I'm just gonna steal this code. Actually, I'll steal the material code. Because this like does partially what I want it to do. I can't type. And yeah, and all my asset files in the engine, they're like just JSON files. JSON files. Do I not have the JSON class in here? I don't remember if it's in core. This. Let's see. So we don't have the name, so I need to change that. Yeah, it really has. The problem with JSON is such a it's such an easy format to parse, and just like it's human readable as well, which is really important. So it's just like, and it's so universal. It's like the OBJ model format too is kind of like the go-to base model format that every basic renderer supports. Is like, can you load an OBJ file? Obviously, there are better model formats than OBJ out there, but you just have to support it, right? Okay, so let's see. Where do I do this? Material. I don't even know what that is. No, I'm gonna have to look that up. VLQ. Is this a model format, or is this a variable length quantity? I actually don't know what that is. And why do I have this huge line right here too? What is this? There we go. Let's see, name. I don't want to get the name. So what is this mad about? This question must have a class. Oh, C string. What is happening? Is this just a fake error? What's going on? No. What do you mean? Oh, it's because I'm using the same name file path. I know. I know. I have that as a to do. It should be easy to set up too. I'm just been lazy about it. Yeah, I know. I'm well aware that I should get Clang D set up. Yeah, yeah. And I have everything I need to generate that too, because I have like this little plugin thing that runs for my. The engine's like driven by this little VS Code plugin to like make running the commands just quicker. So I can hook them up to a hotkey. So like I have all the boilerplate necessary to like generate that file super easily. I just have to actually spend like an afternoon and write it so I can get that set up. All right, let's see. Materials. Why is this so confusing? How do I set this up? It's like I have this like weirdly abstract interface for creating resources. I don't need that. have name either yet, so let's just like. I don't need that. Hey, how's it going? Two wave hands at the same time. Sorry, I'm kind of zoning a little bit. I'm in the zone here while I get this working. I'm like taking code from one place and trying to morph it to work here. And I think I almost have it working. So that gets the texture path from the JSON file, and then it tries to read it as a relative path first. And then if that fails, it tries to read it as an absolute path. And if that fails, fail to load texture file. What a great error message. And then it registers it, and then that should be all I need for that. I need to actually read the MIT mapping portion too, but I'll skip that for now because it's not mission critical. Now I just need to extract the file name from the file itself. And I do this somewhere else, I'm pretty sure. Gather. Yeah, here we go. Does this really take a string? Let's see. Oh, it hates that, doesn't it? That's really annoying. I want to fix that. And this can fail too, I think. Or no, it doesn't fail. Yeah, it shouldn't be too big of a deal. Like I said, I just have to do it. Yeah, because like if I compile in Clang right now, and like I run this, like I'm already generating. Obviously I'm generating like the compile flags. If I go to this project, output, build. Let's see this one. It's like I already have all of my compiler flags here that are being generated to like compile this project with the correct like defines and everything. So it's just a matter of like spitting this out to the compile commands.json file. I just don't have like an easy way of actually doing that at the moment. I need to go in and refactor some stuff so I can kind of just extract that from independently from actually like kicking off a compile. But yeah, it shouldn't be too hard. Okay, so this actually might just work now if I test this out. Let's see. No, it actually won't work because I didn't do. I need to do this. I guess we gather textures first. And then we have to do it right. I can explain this actually because it's kind of interesting. So the way my build system works is I'm not using Ninja CMake, but I do have Ninja obviously because I showed the Ninja file. And so yeah, basically I have this. It's it's kind of a long process to explain. But I have a custom build tool, which is like its own separate little executable that runs, and the build tool is responsible for like gathering all the assets and packing them into the binary file that the game loads at startup. It's responsible for some code generation that gets compiled into like the game's runtime, and that's for stuff like the asset system has some sort of boilerplate code that gets generated from like the asset files, so I can reference assets by like an enum ID within my game code. In the shader, I have a shader language that gets cross-compiled into like HLSL or GLSL depending on what render backend I'm running. So basically, I had to create this separate tool that I just called a build tool, which is what I'm working on right now actually. So then I just decided if I'm doing all of this already, I might as well just make the build tool generate the Ninja file, so I can just circumvent CMake altogether, because it's like if I don't need CMake, because I already have this separate tool that's running, I'm just going to use the build tool. Yeah, so and then I actually have a little bootstrap executable as well that compiles the build tool. So if you don't have the build tool already compiled from like a previous run, or the build tool has changed, like if I'm editing it right now, so obviously it needs to be recompiled. I have a little bootstrap, which is just a single translation unit, just simple C++, one line, one file kind of thing here. So yeah, basically just like it's its own self-contained build system just for the game and the engine. Long story short. And then just to make my life easier when I'm actually working, I have a little VS Code plugin that I have. Yeah, so I have a little VS Code plugin that just like when I click the build and run button or like F5, all this is really doing is I have these little scripts down here, like a batch script. It's just generating a command line and then running the batch script. So like if I want to just run the game without like VS Code, I can just go like boot.bat, the project name, and then there it is, just recompiled the entire project. So that's kind of the high level quick overview of how the build system works. So yeah, for the Clang D, I would probably add that into my VS Code plugin. Because I have certain defines, like right now I have the DirectX 11 render backend that I'm using. So like if I switch this, it's gonna need to change that, like the compile commands to instead include my OpenGL code. So it's kind of a little complicated, but it's certainly doable. Okay, so let me test the texture stuff. I think this should just work now. Let's see. No, those are just that's just me testing the instanced rendering. Yeah, I don't have any lighting code implemented yet. I've been working on the graphics code the last few days, so it's just like an instanced sphere mesh that I'm just rendering like a million times, like 440,000 times or something. Where do I draw the sky? Yeah, so I should be able to just do as a test. What did I name this? I don't remember what I named this. Text sky. This is in the list. It is in the list. And it does work. Okay, that was actually really easy. Okay, so now I can circumvent all this material stuff, which is really nice. So I'm going to get rid of that. Yeah, so these like big spheres I have. I'm just testing out instancing and frustum culling. So I can like, obviously, the classic frustum cull. Nothing too exciting yet. Okay, I need to do the mip map flag as well. So let's see. Get rid of that. I'll call it overcast. Yeah, I am in that little test, yeah. Which isn't too efficient because you're like uploading it every single frame then. Let's see. That works. And now to do the mip map flag. Yeah, I guess I can show that code. It's not very good code. It's kind of ugly code. Yeah, here we go. I just have like this big loop. And then every frame, before I draw it, I just recreate the instance buffer and then write to it if the frustum check, I guess, succeeds. And then right now my little instance buffer just contains an offset and a color. So it draws it as like the grid. Yeah, I'm trying to think of how you do that in like a... Yeah. But yeah, like prior to a week ago, I wasn't even supporting instanced draw calls at all in the engine, so... Yeah, okay. Now... MIP mapping... Hey, how's it going? Yeah, the it's pretty simple in DirectX. I'm using DirectX 11 too, which is like I'm already using an old version of DirectX. I do have plans. I started to work on the metal backend for Mac because I want to deprecate OpenGL because I'm being held back right now by OpenGL 4.1 or 4.3, whichever one the one that Mac supports is like the version before they added support for compute shaders and like a bunch of other stuff. So, and I work on Mac. Yeah. No, I don't have a series. I'm just kind of... I haven't streamed here in like 6 months as well, is the funny part. So I'm just kind of decided to do it again today because I was bored. But yeah, anyway, like I was saying with OpenGL, yeah, so I have a Mac and I work on this like with my Mac every now and then, like when I'm away from home. So I couldn't use Vulkan for Mac because, well, I don't want to use the Molten VK abstraction library for it. So I decided I want to get the engine up and running, so I just use OpenGL because it's easy. But yeah, Mac is annoying because they deprecated OpenGL support after, I think it's 4.1. And yeah, it's just annoying because then it's like, there's a lot of features that came after that. So yeah, I started to work on the metal backend for my renderer, but I haven't gotten too far on that. Let me see, where is it? I have like pretty much nothing actually in the metal backend other than the window. It creates a window now. But yeah, so yeah, DirectX 11 is also pretty easy. But yeah, I'm working on metal, and then Vulkan will be next, because Vulkan will get me, I guess, off of OpenGL entirely once I have metal, Vulkan, and then DirectX. So I kind of want to kill OpenGL, unfortunately. But yeah, so let me see. Back to the instance draw call, or the MIP mapping. I need a flag in my textures to generate MIPs. So maybe I have like a... Yeah, and that's been my experience so far with it too. I have like a separate project where I was just experimenting with setting up Metal because I don't know the Metal API at all besides the experiments I've done. So I did like the classic render a triangle and like, you know, create a shader. So like I've gotten that far in my Metal foray. It's actually kind of a nice API. I just have to get it in the game engine, which is it's just a project, so I have a lot of stuff in here that needs to be added for that. So okay, so where do I generate the MIPS here? Should probably have an error case if you can't generate MIPS. MIP mapping fails. That is a catastrophic moment. And then yeah, and I know like I have like a little bit of experience with Vulkan and DirectX 12 because at my previous job I used to work at a AAA game studio that had their own engine, so obviously their whole render backend was DirectX 12 and Vulkan. So yeah, I worked with it there, but a lot of the code was of course written by other people, so I didn't know it as intimately as if I was writing it myself like I'm doing for this little engine. But yeah, it's like I know it's a lot more explicit in what you need to do, like allocating your own GPU memory and stuff too, and setting up your own memory fences and barriers. And I guess the whole concept of like, it's pretty interesting. There's a lot to say on that. I don't work there anymore, kind of for unrelated reasons. But yeah, it's tough when there's a lot of people working on the same code base, I guess is my main takeaway. Because it's like, at least where I worked, you kind of become very specialized in like what you're hired to do. So, when you write your own code, like your own project, you kind of just know everything that's in there. And like I can just make a change whenever I want to. Whereas when you work in a AAA engine, it's like, and I guess this is true kind of every like large company you work at that has a bunch of people working on the code base. It just becomes like a lot more, I don't know what the right word is for this. A lot more bureaucratic maybe, in terms of how things get added and certain decisions that are made. Yeah, and that's a great point too. With the thing. Yeah, this just makes me think of how much I dislike graphics programming, which is funny because that's what I do as like a job. I do graphics programming. It's like I hate how there are like so many different graphics APIs. You love it. That's great. Yeah, there's like so many graphics APIs, and like each one does things in slightly different ways. So like the goal with my engine is I want to have like a single solution to just make stuff quickly. Like I don't know if you've seen this, like, or I don't know if I said this yet, but in this project, I even went the insane step of writing my own little shader translator. So when I write shader code, like here's my little snow shader. I only have to write this one shader file in my custom little language here. And then this gets translated. So when I'm running DirectX, I have this get basically translated into HLSL. And then the same thing happens for GLSL if I like run OpenGL real quick. Oh, it didn't even work. Okay, I guess, yeah, I still worked on the build. So this generates GLSL code because I just ran the OpenGL backend. So the same exact shader from that shader file. Yeah. So because I was so annoyed, I got so annoyed by having to write the same shader like multiple times for each graphics backend. And I know there are tools out here to do that. Like with Vulkan, I know you have Spurvy bytecode, which you can generate from HLSL or GLSL. And then there's like Spurvy cross, which you can take one and get to the other. But yeah, I don't know. I just decided I didn't want to, I don't know. I got stubborn and I just started writing this. So yeah. But what I do some kind of interesting stuff with this. Sometimes I wonder if it was even worth the effort. But like in the snow shader, like I can define the vertex format for like this shader. And like, so like I have this little struct called like vertex input or instance input. So this is like the per instance format. And when I run the build tool, it actually generates some of the boilerplate C++ code that allows me to just like directly write vertex data from this. So for example, or maybe let's look at like the shader uniforms. That's another example where this is done. Let's see, where do I do this? Yeah, I have like this like shader uniform buffer thing for like basic shader uniforms. So if I want to actually write this in my game, all I have to do is like add a field to this right here. Like say I'm adding a field for like, I don't know, offset Z. And then I can just add this to the input position here, like plus offset uniforms.offset Z. So I can make this quick little change. I'll need to fix my build tool because it's going to break. Let's fix the build tool real quick. Oh, yeah, shoot, I already... See here, I'm running into a problem. I love on-the-fly little cope. I'm coping so hard because I spent all this time adding this feature. Where do I use this? Yeah, I need to add it here. I need to fix my, must have at least one mid-level. Where is it saying that? I shouldn't have changed. I shouldn't have started doing stuff while I was working. Let's just comment this out. Okay, yeah, so like you can change that. Anyway, so I added that field to the uniforms. And then like I can just immediately write to it here through this little interface. It's okay, I'm just coping. So I can like add like an offset here. So now it's offset. And then if I want to, I can hook this up to the console like that. It's not gonna work, is it? Let's just do this. DV. Yeah, so it's like the idea, the reason for why I did it is I wanted to be able to do that kind of stuff really quickly. But yeah, it's a lot of maintenance. So I questioned whether it was worth it, but it's kind of cool. But through that experience, you learn that in OpenGL, they use like STD 140 as like the packing, the alignment for structs, for like uniform buffers. And that HLSL uses its own data alignment scheme, and they're not the same. They're like really similar, but they're not the same. So like if I'm generating a C++ struct for like a uniform buffer or a C buffer, it already does work with Linux, and I can demonstrate that right now. Hold up. I think my stream actually froze. I think my video froze. Has it been frozen this whole time? Here, 1 second. I need to fix my my stream. I'm looking at the output though, and it's like frozen. It's like not moving. I'm trying to. I'm having some technical problems here with the stream. I need to reset this. Because I think for everyone here, it's just like frozen on the one page. And I don't know how long it's been like that. Let's see. Here we go. I fixed it. Yeah, I was trying to show off that it works on Linux. So I'm on Linux now. And if I run, here it is on Linux. So it does work for Linux, and it also works for Mac. So that's cool. Okay, back to Windows. Yeah, so anyway, what was I doing? MIT mapping. So yeah, right. It will never be Unreal Engine. And I guess in my defense, since I'm still working on the, since I was just talking about the shader language thing, in my defense, if you look at engines like Unreal that has the shader blueprints, how does that work internally, right? Shader blueprints just generate shader code from the nodes. So I could make the argument that my custom shader language is just a code version of blueprints, right? I have my own language to write shaders. Yeah, I'm just coping. Yeah, it's about 18 months. It was like early last spring is when I started of 2024. But I've had projects before that. So this is kind of just an adaptation of other stuff I've done in the past. So anyway, just complaining about MIP levels. It's just occasional. I haven't actually worked on it since like, besides this past week and a half, I haven't worked on it all summer. So let's see. I keep getting distracted, which is fine. I'm working. I need to get the maps working because I got the error that I commented out. So let's see. Yeah. So we need to go into the materials. So want to add a material. Let's go like 16 right now. That did not fix it. Why? Interesting. Why is that? What error is that? Why am I hitting this? It should have MIP levels. Let's see. What texture is that? Not even printing the texture. Let's see. Oh, it's getting no MIP levels. When it should be 1. Let's see. I guess that makes sense because I wasn't setting this in here. Well, let's just do this. What do I call this? MIPS? Do that for now. Just sanity. Oh, it still doesn't work. Interesting. Let's see. Okay, but it actually shouldn't fall back to failing in that case. Yeah, and ignore these maps that look like they're made in like 2001. So now we should actually support. I'm just gonna make it generate MIPS. I need like a simple test for MIP mapping. Actually, before I do that, oh, that's right. Yeah, game engine stuff is fun. I think more people should write them. It's quite the project though, depending how deep you go. Okay, now, so that's working. Now there's another refactor I want to do to the way I'm using my graphics API here. So we should get into more graphics code, which is fun. So one thing I realized, for some context of why I'm going to be making these changes. One thing I realized when I was adding the instance rendering support is that So in this little project, this is like my little graphics test bed at the moment. Just have a bunch of random stuff in here. But I added instance rendering, and I'm using it on these little snowflake particles. So if I increase the snow count to like 1,000,000 particles, each of these little snow particles is like an instanced draw call to just like a single 4 vertex quad. And I realized that while I was working on this, you don't actually need an instance like layout. Like you don't need anything in your per instance data to use instance drawing. And I guess when I was initially adding that, I didn't realize that. I kind of expected that if you wanted to have like an instanced rendering of something, you would have some data that's being, uploaded per instance. But you actually don't need that because like a lot of particle systems are purely stateless, meaning you can tell the GPU to like instance render like 100,000 particles. And then in the shader, you can sort of, I guess, from the instance ID that you can just access in the vertex shader, you can generate random pseudo-random numbers from just the ID and basically simulate the entire particle system without having to actually upload any like data per particle. So you can basically have an instance format that's empty. And then I realized that that's also true for vertex formats, in that you don't actually need any vertex data to render vertices. Like you can submit a draw call with no vertex data. You just tell the GPU that you want it to like render 4 vertices. Because you could, like in a mesh shader or a geometry shader, for instance, like generate the actual vertices from like the vertex ID only. So there's like a bit of a refactor I want to make to the way I'm handling vertex buffers and index buffers and instance buffers within the graphics code. So I'm going to do that, or at least start to do that. I'm kind of just rambling a bit, but I'm mentally preparing myself for this. So let's see. Where's graphics? Yeah, so right now I kind of have this ugly... I have a GFX vertex buffer class, which is basically like represents a vertex buffer resource. And this is like the public facing version of the API. And the way you actually draw stuff is like I have like a draw function on the vertex buffer class. So you just like create a vertex buffer and then call draw on it. But if you're submitting a draw call without a vertex buffer, this pattern doesn't work because like I made the assumption that you would always have a vertex buffer in order to submit a draw call, which in hindsight isn't actually that smart. So I'm going to take this stuff off of the class and just have it as like its own thing. So let's see. Yeah, so for example, let me just go up to like, I will just create a little example case of drawing a sphere in the project. Yeah, so like right now, I can just like create a little sphere up here, static sphere. This is just a little class that just has a vertex buffer and index buffer on it. And I can just initialize this at startup. There's just little helper functions. Give it like 20. Make it just all white. then if I want to render this thing, I just come down here somewhere in the render loop, like down here below the frustum draw call. And I can do like sphere.vertexBuffer.draw, right? Or draw index, because it has an index buffer as well. And then like if I go here and compile, this thing should draw down here. Here it is. This little blue sphere. Let me turn off the ray. Yeah, I'm trying my best to not make it too complicated. The premise is that when you draw stuff, you have vertex data, which is like describes the points that make up the triangles. You have index data, which tells the GPU that it can reuse the points on like neighboring triangles. So like if you have two triangles that make up a square, the two corners actually share the vertices. So that's what the index buffer does, is it like tells the graphics card, hey, these 2 points are actually shared between the two triangles that are like adjacent to each other. And then an instance buffer is like another level where it's like, hey, I actually want like 100 of these squares. Don't just draw one, draw 100 of them. And then you can programmatically like determine what happens to each of those 100 instanced squares through the shader that you write. But yeah, through my little interface, I have it so you draw from the vertex buffer, because I made a bad assumption that the vertex buffer will always exist. So instead, I'm going to do it kind of like I do for binding shaders, where it's like drawing is sort of a function that just exists in the graphics module, and then we pass it a vertex buffer if we have one. So I'm going to make that change. So I need to find where I do like shader bind. Let's do like drawing. We have like a few permutations for how you actually draw stuff as well. So here, I can show that. I have a little game I worked on earlier in the year. I was working on a Terraria clone. So I have this game, if it will run. Hopefully it runs. It's not really a game yet, it's kind of just like a Terraria clone. But this is in the engine, and it has a little water physics simulation and sound. And I was working on this pretty much all spring, and then I kind of got busy and I stopped programming for a while. And then I got back into programming again the last couple weeks. And I'm inspired by graphics stuff. I gotta turn the volume down. My ears are getting destroyed. Yeah, I get a little oil. And lava. Oh, there's also here, let me fly over here. Turn it to nighttime. Get some lights in here. Yeah, those lights don't look very good. I guess, I mean, I am kind of working towards it slowly. Like I did start working on this. I was pretty into this for a while. But I don't know. I'm not like in any particular rush. Because I just work on this stuff like part-time. Because I have a full-time job that kind of pays the bills. So like I do this just for fun. And I don't want to burn myself out. And I feel like every time I get a little too like into trying to make a game, I kind of burn myself out. So I find that I enjoy the engine stuff a bit more too. It's just I work for a company that does like mapping software basically, and I do graphics for that. So that's where I like currently work. It's kind of interesting. I used to work at a AAA game studio prior to that, but I switched jobs last year. So I work in... I still do graphics programming. I just don't work in games anymore. But obviously I like doing games. I would say yes, because actually I mostly work with OpenGL at my job right now. But the code base there is actually pretty old, so there's a lot of OpenGL code out there though, and I don't think it would limit you. It is good to know like the I guess modern graphics, the quote unquote modern graphics as well. Just because that's kind of the direction everything's going right now. But I don't know. I feel like if you know one graphics API like fairly in depth, the jump to the other ones isn't that drastic. So yeah. Okay, so anyway, I need to do these draw functions. Unfortunately, I have to template these because my things are templated. I can't type. Template. And this has to be... Yeah, I mean, like I said, it really depends on what you're doing. Yeah, thanks for stopping by. There's actually like a lot of people watching. Kind of surprised. I forget that YouTube changed their algorithm. They actually like push stuff out to people that aren't subscribed to you. So it's like I do a stream and there's like actually a decent number of people on here, which is cool. It inspires me to do them more often. So anyway, what was I doing? Just need to grab. Unfortunately, I'm going to break a lot of code by doing this because I'm going to have to go through and like everywhere I do a draw call, change the code for that, which is also a pain in the ass. So let's see. So I basically just need to do this for all of these. This kills me using templates because I try to avoid templates where possible, but I've unfortunately already, that ship has sailed here. I think it's a custom theme. I like tinted the background, and I have a custom font running. Let me see. Font, theme. How do I get to the theme here again? I have the IO Sevka font, if you're trying to find it. If that's what you mean by theme. IO Sevka. This one. This font. There's a couple different versions of it too. Let's see. Yeah, yeah. I remember I spent like an evening tweaking around with the different settings. Where am I? I'm lost. So I need this here. I think I'm missing one actually. Did I not copy one of these? I didn't copy this one. Can you even access the PlayStation API? I thought you need like an expensive dev license for that. Oh, they just include OpenGL and Vulkan. Oh, they didn't do that. Yeah. Oh, you do have a dev kit. Okay, that's that solves that problem. Yeah, because I worked with it. Yeah, my job when I was in AAA, but obviously the company paid for that, so I was just like exposed to it that way. But yeah, how do you even get a dev kit as like an independent person? I'm sure there's like some thing you can sign up for and pay a bunch of money. I would almost be interested in doing that just for fun, but that sounds like a deep rabbit hole to get into. Okay, I think these functions are done. Now I need to actually like go through and slowly replace everything that uses them, which is going to be horrible. Okay, let's see how much stuff breaks by just doing this. Yeah. Man, this is going to be rough. This is going to be rough. Let's see. Resource. Oh, I'm not doing this. Okay, not as bad, not as bad. So I have to come in here. Oh, that actually wasn't too bad. Let me get to this project. I guess I'm using indexed rendering for most of my stuff, so I actually haven't hit the bad stuff yet. Yeah, I know. I remember that. I remember reading that once. Another world of coding. Alright, so line.draw. I think, I'll say, I think the code looks a lot more complicated than it is. It's like intimidating at first, maybe. It's also easy for me to say that because I'm the one that is working on it, so I'm familiar with it. Alright, that wasn't too bad. So we got that working. Now we just have to go to the next function. It's the draw indexed one that's going to be a pain. Let's see. So once we comment this one out, things are going to... Or no, this one. Things are going to start to break here catastrophically. Because I use this everywhere. Let's see. I think like the font renderer uses this. Oh, I need that as well. Souls boss. Yeah. I'm not even doing anything too exciting right now. I'm literally just like changing my code from working in one way to working in another. I don't want you to feel disappointed. I promise it isn't as bad as it seems. There's like a few fundamental things you need to get familiar with C++. And then I think it all clicks. Because like in the grand scheme of things, I haven't even been using C++ that long. It's like 3 years I've used it, like C++ total. So yeah, I've been programming for a while before that. So I won't like, I'm not trying to like lie, but I wasn't always a C++ user. Okay, that wasn't as bad. I don't know why it just built. I think I hit the wrong key. I'll also say that like I use a flavor of C++ that maybe a lot of people wouldn't. Why am I drawing this here? Interesting. I use like a very C-like. I worked at AAA for just shy of 3.5 years. But yeah, like I was saying, my the version of I guess the style of C++ that I prefer is kind of is very C-like in a lot of ways. Yeah, I like to do data-oriented. I'm not a huge fan of... I don't use anything from the C++ standard library as well. Like for a few reasons, I'll spare the rant on that. Oh, do I not have access to this here? Oh no. That's catastrophic. Okay, I have to move these functions up. See, it's like errors like this, which are really stupid. Like this error here is telling me that this function doesn't exist, right? It's like it can't find this. Because I have, it's down here. It's down in the bottom of the file. It's, yeah, okay, so yeah, the engine is like, I'm not making a renderer. A lot of people use the word game engine like in renderer kind of synonymously. So like you'll think of Unreal that has all the rendering features, like all the PBR lighting pipeline. So like the engine I'm working on right now is like literally the framework for which you can do graphics programming in like the context of making a game. So this little project I have is just like a bare bones renderer that just, I'm testing out the features that like I would need to build a more, I'm trying to think of how to explain it. Like if I were to build an actual renderer that uses like PBR lighting and stuff, I would need these features in order to do that. So I'm working on that part of it right now. So I haven't gotten to the part where I'm actually writing, I guess, high level graphics code for like rendering physically based materials and stuff. I probably could have explained that much clearer, but I clearly did not. So I need to move this up here somewhere. Let's do this up here for now. Hopefully that should work. Oh, but then I don't have access to that. This is not the high level code, unfortunately. Yeah, so here's my little, is that working? Did it just work? Okay, cool, I fixed the problem. So like I have this little test project. So like you see these PS2 style levels, and I have like a few of these. The funny thing is these levels are actually from a game I made like 13 years ago, and I just ported the level format to like work in this project because I wanted something to look at. But like I have these snow particles that are falling down, and the reason that I have snow is because I was working on basically the ability to render a bunch of geometry cheaply. And particle simulations are just rendering a bunch of particles like as efficiently as possible. So like in this test case, I can just like increase the number of snow particles to like, I don't know, 10 million. And like now I have 10 million snow particles. So like I was working over the past week on just the ability to even do this within the engine. The game isn't getting made very soon. Yeah, and like I just showed this off earlier. I'm sure people have joined since then. But I have, oh, this is actually going to break, isn't it? I need to fix this real quick. This is the tough part about streaming while I'm like working on refactor code is that I want to show stuff and then it's broken. So let's see. Here we go. So like I was saying, this is a little 2D game I made in the engine, a little Terraria clone. And there's really not much to this either, but it's like just demonstrating the fact that like you can make games in here. And this is like a game I am kind of working on. Of course, this is 2D, so like the rendering that I needed for this is much easier than the sort of rendering features you need for like a 3D engine. So right now I'm working on getting the features in that I would need for a 3D engine. Because right now my 3D example test project looks like it's from the PS2. So yeah, long story short, it is like a multi-purpose sort of engine is how I'm designing it. And I should caveat that by saying that like I'm just doing this for fun. I'm not trying to like make a product here, because a lot of people get like they'll naturally ask, why are you spending so much time writing an engine when like I don't know, it takes forever. And it's just like I'm just doing it for fun. I just like programming this stuff. Yeah, this little like grid of stuff is just me testing instanced rendering for a bunch of meshes. So there's unfortunately no light probes. It's just drawing a bunch of sphere models really efficiently is what I was testing. And that's like what these little spheres are too. Because I have like some sphere rendering code to generate sphere meshes. So yeah, and right now I'm working on a bit of a refactor to how I was handling submitting draw calls. Because I guess I should explain the engine real quick, is that, because I think someone asked in here. So my engine is general purpose, and it's meant to be abstracted over, yeah, so the engine's meant to, it's cross-platform. So right now I can compile for Mac, Linux, and Windows. Of course, I'm on Windows right now. So to support Mac and Linux, I have an OpenGL backend to like the graphics module, I could call it. So like I can go into the engine here in the backend folder here, and you can see that like I have an OpenGL backend, and this basically implements my graphics code, I guess, calling to OpenGL calls, of course. But then I have the same exact, implementation, except for DirectX when I'm running the DirectX backend. And I will be doing Vulkan as well. I haven't done that yet just because these things take time. So I have a Vulkan module here, but it's currently empty, as you can see. And I have begun working on the Metal one for Mac, but it's also mostly empty, so it's a work in progress. But I have DirectX 11 and OpenGL going. And yeah, so basically the actual API that my game code interacts with is like this sort of abstract. I have it in like a namespace that I just called GFX. And these are all the functions you can call to do anything you want to do, like related to graphics. And then, yeah, so like and right now I'm doing a refactor to how I was interacting with the draw calls. If that makes any sense. I'm just rambling a little bit. But like I'm working on this stuff right now, which is kind of a mess because I have this template nightmare going on, which I'm not a big fan of. But I'm just gonna get it working first, and then eventually I'll come back and clean it. Yeah, I think I missed a question. Yeah, I think I just used some license. I forget. I pulled it from somewhere. I mainly just have that in there because like I personally don't have any intention to like support this as a product other people use. Like I'm just kind of doing it for fun for myself right now. And it's like, it's a good learning project. But of course I have the code on the GitHub. Just, I don't know. I don't want to like gatekeep the code because I don't know, there's no point in doing that. So I think I just put that in there because like I don't want people to have the expectation that they'll download this engine and then think that I'm going to support it in any official capacity because I don't have any plans to do that right now. Oh, it does have physics. It does have some physics, really basic physics. But if I think I can do it here. I have some little sphere bouncing physics. These are the most basic physics that one can have. A sphere bouncing around the screen. Oh, and it has this mouse raycast thing. So like you can see the mouse. I was working on that recently. So as I move the mouse around, you can see like, I don't know how well this shows up on the stream. I wrote the physics. It's really simple. There's like really nothing to it. Let me see where it is. I think it's in 3D. Yeah, I have these functions for where is it actually? I don't remember where it was. Collision maybe? Yeah, I have this function that basically tests a sphere collision against like a mesh of vertices, and then it returns this thing. This is just work in progress. It's really it's really dirty at the moment. I don't have any like rigid body physics implemented, and I don't know if I'm gonna want to write that myself. That might be something that I just use a library for. I'll use like Bullet or something. We'll see. I don't know. Okay, so back to the graphics work. Yeah, so I'm slowly converting these functions over to use the new version. So the great thing about C and C++ is you can just like comment out code and then it will just not compile, and then you fix all the areas it doesn't compile, And then once you do that, you know you've like fixed your code. Like, there we go. Fixed. Let's do this one. I'm not using that anywhere. And then like fix this one. The level, these level files are actually from a game I made like 13 years ago in Game Maker, if you're familiar with the engine Game Maker. And I actually don't remember how they were made back then, but I converted the file to just a raw format that I'm loading in, and that the engine knows how to render. It's basically just broken up into a bunch of meshes of for each material. Yeah, Game Maker is like I don't know. You can just Google it. It's it's kind of it's a I don't know. It's a fun little engine, and that's how I started game development. However long ago, I was using Game Maker, and I just use those meshes because I had them on hand. So I have like a few of these little level meshes, little test maps. There's little okay, I wasn't sure because some people don't know what Game Maker is. Okay, so let's see. I think I only have a couple more. Yeah, I kind of like the. It's funny because like when I made these levels however long ago, it's like they were just low quality because like that was just the best I was able to do back then. But like they're unironically kind of like a neat graphic style, I think. It's like that retro look. All right, unfortunately I didn't have any problems there. All right, back to work. Yeah, you like my my Terraria clone? Terraria 2.0 question mark? What do I make? Do I make Terraria 2.0 or do I make my PS2 style first-person shooter? All right. So now that we have that, we need to add the ability to submit draw calls without actually having a vertex buffer bound, which is going to be fun because I don't support that currently. Let's see, what do I even need to do that? So I need a test shader. So here we go. Let's make a test shader. And we will do it in, I don't even know. Let's do it in this project. I'm after very efficient particles. That's what I want. So we need to add... First, I need to see what happens if I create a shader that doesn't actually have... shader shader particle. So if I have a vertex format that doesn't actually have anything in it, what happens? This is the first great question. Steal some code from here real quick. Okay, so the intended behavior of this shader is it's going to basically render a quad with 4 vertices. Let's see. And like that. See, I don't actually have an in position, so we'll just use position. So let's have like some positions. There's 4 of them. Just gonna hard code some little lookup table right now. So this one's there. I forget what the winding order is for a triangle fan. Or triangle strip, rather. Let's see. Alright, so that, and then, so if I use vertex ID modulo 4, yeah, ignore those. Let's see. Yeah, and then position, let's just have this render like up high in the sky for right now. Just so I can find it. Let's multiply this by some large value just so I can find it. And then I don't need it colored. I guess I don't need a UV either. I'll keep one for now. I guess I'll just draw the UV. As my color. Okay, so I think this is gonna fail. Probably. Yeah, of course it does. What's the issue though? That's not the same problem. Oh yeah, I have an F. I can't have an F in the shader. I'm used to writing float with a .f. And then these are unnecessary. Oh, actually that does work. I'm surprised. I didn't think that was going to compile. Okay, that's exciting. Does it compile for OpenGL too? It does. Is that because I'm in release mode? Yeah, there we go. That's something. So that failed here because that's null pointer. So I guess if that's null pointer, where is that assert hitting? It's not really a game right now. I'm just working on like graphics code. So I'm kind of just doing like game engine stuff rather than game specific stuff. So I have like a few games that I'm kind of working on in the engine, but no like particular project right now. So let me think about this for a second. Wait, so that was null pointer? Yeah, okay. See, if I went to Windows, this will fail. Or MSVC, yeah, it's not gonna like this because you cannot allocate an array of constant size 0 because I'm doing this here. So where do I generate this? Yeah, so I need to do the same thing. Here. No, this is massive. This is a nightmare. And then, is there a way to like quickly jump to the bottom of this? Go to bottom. I don't know. Okay, so that should shut that error up. I have to do the same for OpenGL, I think, or not. Let's see. No, I don't. Good. All right, now we hit this assert. See, because like I had this code that like expects this format to actually have some substance to it. But now that could be possible that it's empty, so we don't want to be just copying null pointers around. And then, let's see. So that solves that problem. Should be 0. actually use that is up here. Let's see. I actually don't have a streaming schedule. This is the first stream I've done in several months, unfortunately. So I don't know. Maybe on Sundays would be like, if I come up with a schedule, it's gonna have to be Sundays, unfortunately. Okay, so we're still doing a mem copy. Why are we still doing a mem copy? Why are we still hitting an assert? I thought I took the assert out. Source description. Oh, I hit the mem copy in the wrong spot. I should be checking this instead. I'm checking the wrong thing, rather. Should be doing that. I misunderstood where the error was. All right, sweet. The fact that things compile without like breaking catastrophically is always a good sign. Now we just need to add an actual function to draw basically an empty, let's see. I'll do it for DirectX first. So I need like 3 of these functions, unfortunately. Maybe I should just have like one overload for this, because this is kind of, oh no, this is fine the way I'm doing that. I need to do, yeah, because it does that. I need to change the name of some of these functions, in fact. For now, I'll just copy this sort of naming scheme and be like RB draw. And we just pass in, we'll start with a vertex count. And we don't need to check any resources because I need to do error checking for this too. Oh, this gets complicated. We don't need to do this because it has no vertex buffer. We need to set the primitive topology. And then just pass the vertex count directly. in theory, if I just call this function in here somewhere, like I set the so bind this shader, so shader particle, and I release it afterwards, and then I just call draw 4 vertices. Will this work? I don't know. No, it does not work. But why? Oh, this is why. Okay, okay. I actually think it did work. But I'm not using the right topology type, because I need to be using a triangle strip. All right, cool. We are drawing a quad without having any vertex data. Now I do the same for OpenGL. Do it once, you gotta do it again. It's like, why have one when you could have 2 for twice the price? Let's see. So it didn't like something. What didn't it like? Oh, I don't have that function. It's annoying because there's so many like permutations of ways that you can draw stuff. It's like, at what point do I stop doing function overloads and start do it like a different way? So what am I thinking? GL. So we need draw, delete that. So we don't have that. We don't have that. We don't do that. I guess we don't do that. It's just this. So that implements that function. Now we're gonna error. Oh, nice. OpenGL is so simple. It just works. OpenGL always just works on the first try. Let's make sure we're not having like an error though. So no errors. It's actually incredible. Okay. I think I'm going to coalesce my draw functions into just like one monolithic one though, because the way I'm currently doing the draw calls is I have like 50 of these like versions of the function that kind of just do the same thing, when instead I could just combine them. And then let's think. Yeah, I can do that. That could work. I'll see to pull the logic out. Okay, let's think. So my draw function, I'm just gonna like name it draw new for now. So it takes in basically everything. So a vertex resource, instance resource, and an index resource. So it's like this one. I'm just gonna copy this one pretty much. Let's see. And then, since I'm passing these things in as pointers, I can just check if they're null pointer. And if they're null pointer, it just won't try to use them, I think is what I'll do. So like, first I'll pass in, do this on reliance. So like you pass in the resource and then you pass in the vertex count. And then you pass in the instance resource. And then you pass in the instance count. And then you pass in the index resource. And index also has a count, I believe. Instance index. No, it does not. Okay, that's nice. It has an index. I guess it does have an index count. I'm gonna pass that in. And then it takes a primitive type. So let's see. So we have like our monolithic draw thing here. And we'll move this later. And then so we assert that it is null or the ID is not null, because that is our failure case. And then we can I'll need to do the error checking later. I'm gonna save that as a to-do. Instance. Background music. I think I have. I assume that's what BGM means. I have the lo-fi hip-hop radio, the live stream playing in the background. Classic. The classic lo-fi. Lo-fi? I'm actually be right back. I need to get some water. So I'm going to be back in a second. All right, I'm back. Make sure my stream isn't frozen. All right, it's looking good. I have my new water bottle. Should really just get a refillable one. Okay. There's so much error checking. Error checking is pain. Let's keep it going though. So that is... Wait, so what happens if I bind a instance buffer? Wait, I need a VAO. Shoot. I didn't think about this. Yeah, I'm gonna do that. So if, let's see. So if this guy is not, oops, that did not copy. So we'll bind that guy. Otherwise, if we don't have a vertex buffer, but we do have an index buffer, we might still need one of these objects. So we'll instead get it from the instance buffer, else if, which means I need to add that back in because I deleted that before. And then, so if, I suppose I can do this here. That binds that, and then if we have an index buffer, we'll bind that. And then we need to pick which one of these will be used, depending on the permutation. What's an efficient way of doing this without just having a giant cascading switch statement or a if statement? So if we don't have anything, then we'll use this one. Otherwise, if we do have, or actually, so that's one case. Else, if we have So we give it a vertex count, 0 instance count type, else if I guess this is the last case. Or no, you have this permutation. How does draw indexed work? Oh no, this is horrible. So is vertex count the same as the index count? Current. It says vertex count times the indice to vertice ratio. What does that even mean? Oh, it's like how many vertices there should be with the index buffer. Which is just the that's so confusing. Here, let me just pull this out here. I guess would I take an index count? Seems kind of random. I don't need that. This, I mean, because I'm calculating that here through this weird, like, so it's the vertex count times that, which is like some weird ratio. Okay, and that is all of the permutations there. So we return true. All right, now I just have to do this part. Even though it should be unused, I think. Why am I not freeing this? What's going on? Did I delete that? I can draw a triangle, yes. I'm just working on a bit of a refactor to the draw code. Wait, what? Is not a member? Draw new? How's it not a member? Let's copy that. Oh, I see what's going on. I have that namespace prefixed. Yeah, I can draw a lot of triangles. They're just not very pretty. I gotta up the snow particles. The snow is underwhelming at the low number of particles I have. Let's get this thing at like 500,000 by default. There we go. It's the best way to make the stream turn into compression confetti. Okay, back to this. Why am I not freeing the Oh, I'm doing it in release. Yeah, of course. Do I even need to bind this here? Why am I binding that? I don't think I need to do that there. Yeah. I don't think you need a solid. Well, it depends what you define by solid. If you're doing graphics code, it's the most important thing is knowing how to work with like linear algebra. So like if you understand how matrices work and just generally like the transforms kind of needed for the graphics pipeline, that'll get you a long way. But of course you can kind of dive down the rabbit hole infinitely far. So yeah, it's kind of as far as you want to go with it. Okay, so we're gonna initialize that. And then I'm not really focused on the actual renderer specifics right now. I'm working on the engine code because for context, I assume you just joined the live stream. This engine is written like fully from scratch, so I'm not using like a graphics library to abstract the like I'm not using like SDL or anything, or like GLFW to abstract my renderer API. I am like writing the render API. So I'm like talking to DirectX and OpenGL directly, and I'm currently working on that code for drawing stuff. So how I actually decide to render a game, it's kind of like up to the game that I'm gonna make. But like in order to set up a path tracer or like a deferred renderer, you just need the code to like create a G buffer, right? And like work with graphics, GPU resources. So I'm just working on that right now because it's kind of fun. And I'm refactoring the draw code at the moment because I was doing kind of a stupid, where I made a naive assumption about how to structure the draw submission code that in hindsight I realized was not the best way of doing it. So I'm just fixing that. So yeah, in theory I can just replace my current calls with this one. Do I have access to this indice to vertice ratio? Where do I calculate this? Equals. So I should have that on the GPU on this side as well. Yeah, pretty much. This is the crux of the problem. So I'm working right now specifically on the OpenGL code. But in like probably 10 or 20 minutes, I'm going to have to do the same changes, but for DirectX. And I don't have Vulkan implemented yet, but that's on the roadmap in the future. Let's see. Make sure it still compiles. Okay, so now if I like, shouldn't be too hard. I've started working on Metal. I have a bit of code for this implemented. Most of this is like empty actually, so I'm not too far. But yeah, I have started that work, and that's actually the next on my to do, because the only reason I have OpenGL right now is because I want to run on Mac, and I just implemented OpenGL for Mac at the moment. Okay, so if I start replacing these functions, where is this? GFX. I mean, you can, yeah, well the problem with Mac is that they don't support Vulkan natively. You have to use like a emulation layer, which redirects Vulkan calls through like an emulator to Metal. So yeah, you can't, you might, and I don't even know if that works on iOS yet. It might be supported. But I think I'm just gonna bite the bullet and do Metal support, just so like I don't have to worry with that. Okay, so let's change this draw call to use my new function. So let's see. Yeah, vertex buffer dot resource. I think I can just pass that. And then null pointer 0, null pointer 0. In theory, these should do the exact same thing as what's currently happening. And it doesn't work, of course. Why not? What now? Cannot convert argument 3 from null pointer to a null pointer. Oh yeah, of course you can't do that, because it needs to point to something. Oh, that's unfortunate. Why am I even passing this in as a reference, I guess, is the next big question I have. I don't even need to pass this as a reference. Why would I be doing that? In what situation does that make any sense? These shouldn't even be these should be constant. Yeah, there we go. All right, getting somewhere. Can I make these constant? Give a constant pointer. Just const these guys, because these are not going to change. The legendary pointer reference. Why would I? It's like I want to change the pointer. Yeah, that's some great stuff right there. Yeah. This is a good thing about revisiting code a while after writing it, is you realize you're doing stupid stuff. And I see I'm doing this a lot here, so I'm glad that I'm rewriting this or refactoring some of this. Okay, now if we just slowly start phasing out these old functions. Let's see. So we had draw. Where were they? Let's just do them all in one go and fix the ones that break. So for text buffer, and then we also have an instance buffer. And instance. All right. We have a catastrophic problem. Let's see. Why did that happen? Instance count. It did not like that. Yeah, that'd be cool. I don't use AI too much on coding stuff. Sometimes. I'm sure it could be good for stuff like that though. Like a project-wide sanity check on stupid stuff. At least have it like tell you what it sees. So what am I doing wrong for text? Did I just mess this up? So if you have a instance, am I using the right draw call? Should be going through this one. A little print line debugging, printf debugging. Yeah, it is using the correct one. What's wrong with this? Did I pass the wrong parameters to it? No, looks fine. I do, well, software engineering, so the same as I'm doing here. I do graphics work for a company that does mapping software, like globe rendering and that kind of stuff. And then I got that job recently. Prior to that, I worked at a AAA game company doing engine work, which explains why I'm doing game engine stuff for fun. So what's wrong? I think like 18 years since I like started as a kid. This is trippy, look at this. It's like stretching the particles out in some like crazy way. It's interesting because this call works. Oh wait, no, that's using the old path still. Okay, let me figure this out. So if index not equal no pointer as well, just for very sanity's sake. Is it current that's throwing it off, maybe? Oh wait, I'm passing a null pointer to... count. Interesting. Yeah, I mean, actually, I can relate to that. Because college, university, made me hate coding. I think it was like the computer science program. Because like in the CS classes, you learn a lot of theory, and you kind of like learn a lot of stuff that, at least me personally, there was like a lot of classes I had to take that I just wasn't interested in at all. So it's like a lot more fun when you program stuff that's actually interesting. And yeah, pretty much you start with main.cvp and grind. Okay, I'm like at a loss right now. I don't know what's going on. Let's see. Oh, it's different this time. Look at that. I didn't even change anything. It's different. It's RNG. I have RNG snow right now. Look at that. Some runs you get like the crazy snow all over the screen. And then other runs you get like the particles that are half cut off, which tells me that I'm just simply not sending data correctly to the GPU, because it's using like some whatever happens to be in RAM at that point is probably what it's using. What does this return? Am I even sending sane values to these? I think vertex count is fine. I should see like 4 and then the number of instances that I have. So it should be like 4 and 50,000, but instead I'm getting 8 million and 8. Oh, I know what's happening. Current is not... Okay, I have to do divided by size of vertex. I should just pull those out to like a macro or something. Still not correct though. Great. Is it stride? What's it? Vertex. I init this thing. So what's the stride? Stride. Size of, which is fine. What size? So wait, I'm multiplying the size by... Yeah, Unity, Unreal. I don't really have any strong opinions on them. I've actually never used either of them. Well, I've used Unity a little bit in some of my university projects. We had to use Unity to make... I made a VR game in Unity as a little project. I don't know. They're good engines. They're big. They have big teams. I'm personally just not too interested in using it because I like I like programming stuff, whereas in Unreal or Unity, it's like that's already done for you. So yeah, and then what's it like on AAA projects? It's kind of just, it's kind of what I'm doing right now, but you have a lot of people also contributing and maintaining the code. So it's like, and the way it worked, at least at the company I worked at, is that like you're hired on for like pretty specific things. Like when I worked there, I was hired as a graphics engineer, which meant that like, despite working in the code base, I really only spent my time working on like specific graphics features. There's a lot of kind of just process that goes with actually like getting code changed and submitted. Just because like a lot of people obviously depend on the game, like the engine functioning. So it's just like a lot more thorough with everything you have to do versus like when I work on just stuff right now, I can just like break code and then fix it and it's fine. I've resorted to print debugging. These are the numbers I expect right here, so this should be working. It should be 4 and that 500,000. So the fact that that's not working is a bit confusing. Instance count. I will just pull these out here as well. That's so odd. I'm actually confused what's happening here. Oh, I'm not passing type. Duh. I'm not passing it here either. I'm like, why isn't it working? It's because I'm not passing the correct... I'm just like not passing all my variables. Sanity is out the door. Okay, let's do this one. So instance count is just that. I'm from United States. Wisconsin, specifically, if you care. The Midwest. Okay, let's see. America. And yeah, hundreds. Yeah, that's accurate, I would say. Depends on the company, of course, but I worked at a company that had hundreds. I worked for Activision, for context. But I don't work there anymore, I should say. Okay, let's see, indexed. There's like a million permutations of how you can draw stuff. This is insane. Okay, let's see. So I don't have an instance count. For text buffer, instance is no pointer. Yeah, I have no comment on that. I refer all questions to Activision Blizzard Publishing Company. I mean, I do know the reason. It's kind of interesting, but it's just the way the game is like shipped. I guess it's the way the core architecture of how the game is like handles its data. Unfortunately, means that there's a lot of duplicated assets between the different like game modes, and it's kind of a relic of the past in some ways. Okay, let's get this over there. Let's just break these out into their own lines, just so it's obvious what's happening. I can delete that. This is actually really nice because this actually saves me a lot of duplicated code. Yeah, I have no comment. No comment. No, that's not the actual reason. But I can see how it's does appear that way. I don't even disagree with the problem. Okay. Now we need to do this exact same thing, but on DirectX, which is exciting. Let's see. So let's copy this monolithic function up towards the top. And grab this, since it should be identical between the two. Oh, what just happened? I'm kind of surprised that people are actually watching this. I just stream because like I don't know what is going on. Stop. There we go. Hitting the wrong key. Yeah, like I said, I haven't like streamed or posted a video in like 6 months, and it's kind of funny that there's people watching. I like how I'm just commenting out my error handling code. Classic. Let's see. Oh no, this is annoying. Thankfully I can copy this conditional crazy thing because I'm gonna be reusing that. Why do I have like such a crazy function here with like 3 zeros? Yeah, I think starting a project like this, or just any large project, is like a really great way to learn. Because like, I don't know, there's just so many, like even like I'm doing this even just personally to learn to get better at like architecting stuff. Like I'm refactoring code right now because it's like over time I'm just realizing that this can be done in a different way, and it's, I don't know, it's just interesting. What did I just do? Oh, I used the wrong function. Count, is this count? Sorry, I'm like really in the zone with this code fix right now. Been programming for like, it depends how I define the start year of when I started programming. It's like 15 years, I would say, of actual programming, but like 19 years of being at least exposed to it. Because I started in 2007 or 2006. No, 18 years of being exposed to it. Yeah, because I started in 2007. It was like my first ever exposure. But I was like a kid back then, of course. I'm not that old. So I didn't really start getting like serious about it till I was a little older. Okay, what's the issue? Okay, so that submits the draw, and then we just have to fix this stuff here. So that's the set the vertex. See, here's the difference. See, this was interesting when you work on multiple graphics APIs at the same time. So this code here is how you tell DirectX how you want it to interpret the data that you're giving it, like to draw. So you set these vertex buffers, and you have to tell it basically where the buffer is, and then like the stride, the bytes per vertex. And in OpenGL, this is like how you do the same thing. You like bind the buffer, but you don't have to tell it the stride. Or like you call the function twice for like the vertex buffer and the instance buffer. Whereas in DirectX, if you have a vertex buffer and an instance buffer, you have to pass it in as like an array to this function. So if I only have a vertex buffer, I need to like build this array to only contain the vertex buffer, which is kind of annoying because that's like extra permutation to the code. But I guess I can do that down here in this kind of monolithic little function. So like anywhere I have, well, actually, no, I can't do that there, can I? What is this? What's this? What's the first value to this? What got me into programming? I just wanted to make games, I guess, when I was a kid. Because I started using Game Maker software when I was younger. And I used that for a long time. So start slot. So I'm just gonna mess around with this until I figure out what I need to do. So I can have an array of 2 of these things because I know there will at most, there will be 2 of them at most ever. I can store an integer. So if we have we'll initialize it as null pointer as well. 0, 0 respectively. Just make sure this thing is. So if we have a vertex buffer, then we know buffer would be this. And if we have an instance buffer, then we know, what is this supposed to be? It's a uint. So now we set that up, and we pass count. And if we have an index buffer, we'll do that. And then this is unnecessary. Okay, in theory, I think that should work. But it doesn't, of course it doesn't. Why would it work on the first try? Because I'm doing this. Of course, that's why. There we go. Now, the most satisfying part about this is I can just come in and delete all of this code. You should always strive to have less code. That's so satisfying. All right. So we can delete that. And out here, we can delete all of that. It looks more complicated than it is, I promise. All right, so it didn't find this. I'm actually calling this in random places. That's crazy. Should be draw so satisfying when you just delete code and it just works. Oh, it doesn't work here though. Of course it doesn't. Why would it? Oh, I didn't delete this function. That's why I missed this one. And then the next step of this is we actually have to do error checking, which I completely skipped because who likes to do error checking? Nobody. Let's see, I don't know what to name some of these functions. It's like, so draw like vertices. It should be like draw vertices or something. Draw vertices. So like here's like draw vertices instanced. We take instance count as well. So we have, and then we have like 4 permutations of drawing without a vertex buffer. So we have like draw vertices indexed, which will take an index buffer, which is down here somewhere. Here it is. And where is it? That can be const. This is what's annoying about graphics code is that like you don't just have one way of drawing stuff. You have like, oh, what if you want to draw stuff in this situation? But like, oh, it's a little more efficient if we draw it instanced. So it's like you have an entire path that needs to be dedicated to drawing it, this other variation. And you kind of want to use all of these in different scenarios. So it's like it is worthwhile to implement them. But it's just like, it's hard to answer that question. I think I got really lucky when I got the job that I did because it was like right place, right time kind of thing. And at the time, I wasn't writing code like this back then, like not even close. I did have some like basic rendering stuff on my, like I had a little portfolio website with some downloadable like executables. So I had a deferred renderer, just a basic one. And I had some game projects. And I got lucky because I applied like right after I graduated to a company that was local to the town that I went to college. And it just worked out. So unfortunately I can't answer that because I just think I got lucky, which is such an unsatisfying answer. You don't need to be like a wizard though. I know that from experience. It's like generally if you can, it does depend what you're trying to apply for. Yes and no. I learned a ton at my job, so I think it's worth it for that. I don't work there. I don't work at that company anymore, though. I actually left the games industry last year. But it wasn't because it wasn't like anything that was wrong with the company. I just didn't want to work. Unfortunately, I didn't want to work in an office. And they were doing the return to office thing, and I was not super thrilled about doing that. So I got a different job that's still doing graphics programming, just not in the games industry. But yeah, like I said, it really is just like, it depends. Okay, so what did I break? I break stuff all the time. Okay. So vertex count, index buffer, vertex instance count. The scary change all. Wait, I can get rid of this. Oh. This is really annoying. Okay, yeah, all right. Oh no, I don't want to do that. I just have these nice meaty functions, but I think this is all the permutations I have of this that I actually care about. Okay, now we can test the, so yeah, here's my, this is a quad. Oh, let's test DirectX too. Make sure we didn't miss anything. Yeah, so this here, this quad was the original goal. No, I'm not using CMake. I have a custom build pipeline set up, which is quite the tangent to talk about. I'm using Ninja build though for the actual like compilation, but I have my own build pipeline that runs that generates Ninja files to compile, which is actually what CMake does internally. Is it generates a Ninja file. Okay, let me see. So now let's draw this thing, but instanced, and we will offset it by the instance ID to verify. So we'll do like float z offset equals sv instance ID times, we'll go like 8 units of offset. Let's do offset. Actually, I could have just done... So I can do the offset there. So this should do nothing right now, because I'm only drawing one of these. But if I go back in to main, wherever that went, and where am I drawing my quad? Here I am. Oh, see, I'm missing one. I'm missing one already. I need a version that has an instance buffer. And then I also need to do that here. This is such a mess. I'm just gonna put these all on their own dedicated line. Why not? Let's really stretch these out. Just for consistency's sake. Okay. Yeah, so this should do nothing still. Oh, I messed up. This. Where is it? Mad. Cannot convert from. What's it mad about? Cannot convert from to a what? What is it mad about? Oh. Yeah, I see. Oh, yeah, this is such a pain. Why did I ever think it was a good idea to use pointer references? Okay. So now it's just mad about this one, so we make that change here as well. And we have broken our triangle. Because we didn't give it an instance count, of course. All right, so now if we up this to like 8, we should see a stack of them, but we don't. Interesting. Why is that? Do we see a stack with OpenGL? Is the big question. No, we do not. Interesting, interesting. Vertex instance. Is it because I'm not even looking at it. I'm using MSVC right now. I can switch between Clang, GCC, and MSVC though pretty easily. Draw instance. So which draw call is it? Oh, it's not even using the instance draw call. Look at that. Interesting. Am I not calling that right there? Draw instance. Which should call to OpenGL. And if that is null pointer, and that's null pointer. Oh, I see. Well, I guess this should actually be yeah, I messed up this logic. So if vertex count is greater than 0 and index count instance count equals 0, else I guess if instance count is greater than 0, we will use draw instance, else we'll just use the regular draw. And then if index resource is null pointer, we do that path. Otherwise, we need to call the index versions of these, which means we can store that. This is actually better. So now we can call draw indexed and draw instance indexed. I guess this is greater than 1, because there might be... Oh, I'll do greater than 0. There we go. That's the stack I was hoping to see. Yeah, to answer your question, yeah, I can. I have MSVC up right now, but I can actually change in real time, so I can just like switch to LLVM with Clang, and that was with Clang, and GCC as well, or G++, I guess, because I'm compiling C++, and I have a ton of error warnings in the output. Okay. But I'm just gonna, actually I'll use LLVM because it's faster. So I need to fix that with DirectX. Because the logic is exactly the same. Well, not exactly the same, but close. There we go, parity. A parity between DirectX and OpenGL. Now I want to rename and move that function as well. What does it call, like RB draw? And then this can be over here in its own little area, which is right above that at the bottom. Yeah, I'm using DirectX and also OpenGL at the moment. And let's see, I kind of want to move these to lambda expressions, maybe. Because I have these all at the top, which doesn't make a ton of sense why I'm putting them up there. Yeah, I don't know when you joined, but I've just finished a somewhat significant refactor of some of my drawing code. Which is pretty exciting. Yeah, the Cherno videos are pretty good. I like him. He's got some good stuff. Yeah, I guess since you just joined, I can give some context. This little project I have right here is like basically just a test bed for various graphics backend code that I'm working on at the moment. So this isn't like what you're seeing right here isn't actually it's not a game. It's just like a test application, I guess. And I've been working on just rendering different ways that you can render stuff. And I just finished, well, first I fixed the instance rendering sort of code paths for my engine. And then I decided I wanted to change some organization stuff. And in that came a refactor of my draw code. So like the functions that actually submit the draw calls. And I just finished that, which is pretty fun. So what you're looking at here, this crazy stack of quads, squares. I'm actually, I'm rendering this with no vertex information or instance information. So like I'm submitting a draw call to the graphics card with just nothing in it except a number, like a vertex count, how many vertices I want it to render, and then like how many times I want it to do that, the index count or the instance count. And then I'm from that, like from the vertex ID itself as like the only input, I'm generating these quads, which is kind of a thing you would do with like a particle simulation, kind of like you can see with the snow particles that are falling around me. To like render millions of snow particles really fast, you kind of just want to have like as little data being sent and processed by the graphics card as possible. And up until today, I couldn't actually render like without actually passing data to the graphic, like to the shader. But I have that working now. So like what I could do is I could now refactor the snow to use the same method as I'm doing for these quads here. So you know, I might as well just do that just to see how fast see if it makes any performance improvement at all. Oh, I also need to do error checking, so I guess I'm not fully done yet. Unfortunately. Yeah. But because I want to look at the snow, I'm gonna do the same thing I just did here. So like yeah, thanks for stopping by. Glad I could entertain you for a while. Yeah, I should get that stuff loading in there. I would need to write a importer for that model. FY Snow. Yeah, I need more test models, test maps. Okay, so this will probably break immediately. Yeah, so I'm updating the snow to not use any vertex data now. And we'll see if we can get that to work. So I don't even need a vertex buffer. So anywhere it tries to use one, just comment that out. And then comment that out, draw. See, now I can call this function instead, draw vertices instance, and I pass it 4 vertices, and it does not work. Of course it doesn't work. Maybe I have to recompile. All right, so it doesn't work. Why not? Oh yeah, yeah. So this thing at the bottom is it's a VS Code extension that I wrote that basically just adds these little buttons down here. And it's kind of like, it just like parses my working directory here. So like, cause I can have different projects that I can switch between, like little games. But yeah, so what it does, the VS Code extension just does that. And then it basically builds a command line, like command. And it calls to my, I have a little boot script that you can use to run the game. So like if I want to build like the thing without using VS Code, I can just call this. That is so tiny. So like pass it the project, and then it just compiles. So that, yeah, that just like recompiled the whole project right there. And like I can pass it like the graphics backend. So if I want to use D3D11, now it's running with DirectX. Yeah, but so what the VS Code plugin does is it just generates these commands based on the buttons that I have configured, just so I don't have to like manually type that stuff in all the time. And then I have it configured to a hotkey, so it's like F5 can just build and run. And then here's like the shell script for Mac and Linux. Yeah, I just kind of like came up with it. It's because like I don't want to tie the code base to like a specific IDE or anything. So like I've designed it to all be driven through these like shell scripts basically. But at the same time, it's nice to have kind of an IDE experience. So doing the little VS Code plugin kind of lets that happen. And it's kind of cool. But yeah, this only works for like this code base. So it's very like use case specific, I guess. I have to figure out why this didn't work. I thought that would work. Is it because of DirectX? The render doc. Okay, so we draw our snow at like the end. Draw indexed. What's the input here? One of these should be my snow particle. Is it this one? Yeah, this one. Draw instance, that is working. Interesting. Yeah, I work at a company that does mapping, like map software. I guess is like the highest level I can explain it. It does like rendering stuff to a 3D globe, and I do graphics work there currently. And then before that, I worked at Activision as a graphics engineer for a few years because I like doing game stuff. Let's see, particle. Here, let me just copy and paste this directly. I wonder if I'm only getting like one of the vertices. Position. I'm not like reusing position, am I? It's like impossible to know what the what the problem is. The good thing, oh, it does work on OpenGL. Okay, I'm running into a DirectX specific issue right now, I guess, because that works perfectly fine on OpenGL. So I guess interesting. So it works on OpenGL, but it does not work on DirectX. Yeah, that could explain it. It's not. So I think I know what's happening. It's because I'm passing 0 to one of these functions. So this is going to break everything else, I think. No. Let me see. It's not. So if there we go. Yeah, so now I'm rendering this snow without any vertex data. I don't even know if that's any faster though. Actually, it is pretty fast. It's like 1,000 FPS drawing a ton of stuff on the screen. Oh yeah, I didn't even show off my the other fun feature. Here, let me turn the snow back on. I can change the here, let me turn the ray off. I can change the color of the fog in real time. Check this out. You get this like this radioactive looking snow fog for this radioactive industrial PS2 style little test map here. Okay, I still have this little sphere drawing. Why am I even drawing this? See, soon the fun stuff, can begin, where I actually write a renderer that looks like it's not from the PS2 era. Sorry, I'm taking a little mental break. I just did a bunch of code refactor. I'm actually not sure what I'm going to work on next. I didn't expect to finish that so quickly. I expected more headaches. It's nasty, like, blend mode going on here with these triangles. Oh, I can turn the snow speed as well to snow speed. I can pause it in the air. This is just crazy. It's probably nuking the compression on the live stream. All right, what to do next? There's quite a bit. I can do the error checking that I've been procrastinating. Okay. I actually have DirectX and OpenGL right now. I don't have Vulkan yet. But yeah, I do run... Well, it's one renderer, but I compile the backend, I call it, depending on which one I want to, like, use for the executable. So I have both, like, I have this, so kind of the basic structure of the project is I have this directory called Manta, which is like the engine library. And then within it, there's on the left side here, just in case you can see, within it, there's a GFX, source file. And this is like the graphics API that you have like exposed to you publicly when you use the game engine library. And it's like here we go. You just have a bunch of stuff like setting, I don't know, the viewport and like the rasterizer state, fill mode. And today I just did a lot of work on the draw calls. But yeah, you use these functions when you like actually want to draw stuff in the game. But the implementation for these happens I actually just, since I have my own build tool, I just only compile like the DirectX 11 is what I'm using here. That's what I was working on. So like here's the DirectX 11 implementation of the backend draw function. It eventually calls to like the D311 context, like draw instance, draw index, etc. But then I have these exact same functions, like this RB draw, render backend draw, in OpenGL here, except this obviously calls OpenGL stuff. And then this source file, the CPP file, depending on which backend I pass to my like build tool as a flag to the I don't know, when you just send it on the command line argument, it will either include the OpenGL source file and compile against that, or it'll compile the D3D11 source file. And I've started working on the metal one as well for Mac. I just haven't implemented most of these functions, so it doesn't actually work yet. But in the actual like runtime executable of the game, it only has like, if I've compiled it with DirectX, that's the only renderer it's running. And if like, because some game engines, they like let you switch between DirectX or Metal or OpenGL like at runtime. Like I know like if you play like Red Dead Redemption 2, you can switch between DirectX and Vulkan just by going in the game settings. I decided not to just have two sets of renderers in the game at one time, because realistically, how often is the end user actually gonna care about? Yeah, exactly. Yep, that's exactly what I do. Yeah, I follow. Yeah, so that's the philosophy, and I do the same thing with the windowing as well, because I run on, like, I can demonstrate here, because this is cross-platform as well, which is why I'm actually using all these renderers. I think someone asked earlier, why use DirectX if you can just use OpenGL? So if you can see my screen, which it doesn't want to work, I guess. One second. My the stream is obviously not going to cooperate with me. Get a nice black screen. Here, I can fix it. Here we go. No video. It just died. Every time I want to show it off, it dies. There we go. Yeah, okay, so this is Linux. So this is Linux. I have an install of Debian running for Linux, because I want the game to work on Linux too. So if you compile on Linux, like, you don't have DirectX on Linux, obviously. So I use OpenGL right now. But I do the same philosophy for the game, the window, zoom in, window management, because I'm not using a library for that either, because I'm crazy for some reason. But like for when I create the actual game window itself, if I'm on Linux, it uses Xwindow API. So I have like a window init class here somewhere. Here we go. And this calls like creating an X window, and then does a bunch of other stuff to like handle window resizing and stuff. But if I'm on Windows, obviously I'll use the Windows like Win API, wherever my init function is for that. And it works the same way. It's just like, depending on the platform, it just conditionally compiles either the Windows source file or the X11. And like Mac uses Cocoa, it's called, for handling the window. And Mac's actually kind of gross because you have to use Objective-C++. So it's like this weird hybrid Objective-C, C++ combo. But like this is how you create a window on Mac, which is kind of crazy. And the same concept for like the threading interface. So Windows uses its own threading thing versus Mac and Linux, which use the POSIX thread, the P thread. So yeah, it's all kind of the same philosophy, I guess. Here we go, back on Windows. I have a button that lets me switch between Mac, a PC that has Windows installed, and in a different computer with Linux. So when I'm testing, it's like not a pain. I just have like a crappy computer I have Linux installed on. Okay. Error checking, everyone's favorite thing in the world. So I did this without doing any error checking. Yeah. Yeah, I've never actually used Rust. I'm kind of afraid to try it. I'm afraid to try it because like I might end up loving it, and then I'll want to rewrite everything in Rust. And I just don't even want to risk that happening because I've gone so far. Maybe in the future I'll do something like that. Let's see. So we'll do the error for this over here. And this error can be done here. Yeah, I did. I feel like I'm answering these questions many times, which is fine because obviously people come and go. I'm sorry if people have been here for a while and I'm just repeating myself. But yeah, I do software engineering as a full-time job. So this is just for fun on the side. I guess I'm already doing this. Maybe I could have kept this error checking the same. Or no, this wasn't even the same problem. It's like you put this error checking stuff in because you want to like validate that. I really should. I need to figure out how to set that up. If I stream more regularly, I'll consider doing that. This was kind of a bit of a one-off, but it's kind of fun. There's a lot more people joined here than I expected. So I might do this more often again. So here we go. So I guess this is just... Yeah. I'm never sure with the streams because like a lot of the times I work on stuff that's just not very interesting. Like this is kind of interesting because it's like graphics work, which is like visual. But even still, I spent like a good portion of today's stream just like cutting and pasting code and renaming stuff. And right now I'm just like verifying that error checking works. And if it works, I should see no problems. So it's like, yeah. All right. Just making sure to actually commit all this code. Before I lose it. Now let's make sure the other games work. And yeah. Yeah, so for anyone who just joined, this is a little 2D game that I was working on. A little Terraria clone in the engine. The audio is so loud. It's kind of good to see that these other projects still work too, after like doing big changes like that. Yeah. Well, it's kind of like, I don't know. It's certainly in development. Yeah, this project's kind of fun because I did this water simulation, which was actually pretty tricky to figure out. I was trying to make Terraria too, basically. I was doing this earlier in the spring. I haven't worked on this too much recently. I'm happy with how the water physics came out, though. And then like the nice lava interaction. It's not really a game right now. It's more like a water physics sandbox with blocks. Oh yeah, it has a, let me turn it back to daytime. And delete, let's just teleport somewhere. One of the last things I worked on before I kind of stopped on this is I added stained glass. So it like tints the light based on the color of the block. So if I put like a blue one down here, get some blue kind of leaching through here. Need like a white light. Yeah, obviously this is a 2D game, so when I was working on this, I didn't need as complicated of graphics features. But I was, yeah, I've just been working on fleshing out sort of the 3D capabilities, which is what that other little project is. This is my little test bed. I have a few other things in here too. Like I have a little chess simulator. This will work. I can play chess. Yeah, let's go to this guy. What else do I have? I think that's it. I really don't have too many. Is this the fluid simulation? I think it does actually. It's been a while since I wrote this, so I don't even remember what that rule is. But if I look in the comments, I think it does have that. Because I remember I was specifically... Did I make a comment on that? No, I didn't. I guess not. Here, let me look at the code. I remember because I had to rewrite it to like support that. Maybe I spelled Passana wrong. Yeah, here we go. I have some code to support this. And what are these massive lines? What is that rule again? I forgot. Isn't it like you can diagonal twice based on some rule? I have to look that up. I need a demonstration. Oh yeah, here we go, here we go. I can recreate the scene here. So you go here. And then how does this work? Or maybe I need to do this first? No. I need to be one more. Hold up. I can do this. Yeah, if that pawn just did a 2-space move. Okay, yeah, okay, I think I understand. So if I get like this guy here, yeah, here we go. Oh, it doesn't even delete the guy. So maybe it doesn't work. Yeah. Or here, let me think. Let me try this again. Let me get a fresh slate here. I don't have the turns actually implemented, so you can just skip ahead. So wait, if white moves 2 spaces, black is there. I think I didn't implement the turns. Yeah, because it doesn't work. That should have captured him. Well, I guess I don't have it implemented. I have code to like try and support it though. So I gave it a good shot. What else do I have? Yeah, here's the fluid simulation in isolation too. I think I can draw. This was a nightmare to get working, by the way, because I do not have a background in fluid simulation, so this was like an actual grind to get this to work. But I'm really happy with it. It's also really performant too. Like I can uncap the frame rate and it runs super fast. Like I'm getting like 2,000 frames a second right now doing this. Yeah, it was really tricky because the game world, obviously you can like move around the world. So it's broken up by chunks. So it's like, not only does it need to be like a water simulation, but it needs to be aware of like the chunk boundaries and stuff. Because like if you move around and the chunk unloads, the water simulation has to like be able to account for that. So that's why this little simulation has these chunks that I can turn on. You can like unload them. When we load them back into memory, they like regain their previous state. Yeah, this was a nightmare. I'm really happy with how smooth it is though. It needs like a nice, pretty, like water caustics shader or something. Like a pixelated shader. All right, I'm getting distracted. What else? Oh, yeah, the question. Am I on stream? No, actually, this is like the first day I've streamed in a long time. But I might stream more often. Because this is actually pretty fun. I don't have a ton of time to work on this though, unfortunately. So this is why it's like, everything's so stretched out. But I've been working on this for a while, just chipping away. And today I had a good day for being productive. Now I'm kind of inspired to actually do a renderer. Yeah, I have so much left on the to-do list though. Like I have to get a collision system working, I guess more fully than it is right now. Let me turn the snow off real quick. Because I started working on like a basic collision system. So I have like this sphere that bounces around. So like I can do sphere versus triangle mesh collisions, and it like actually kind of works. It's kind of jittery, isn't it? Sphere kind of jitters around. But the little balls here can't actually collide with each other, so it's not a rigid body simulation. It's just like one sphere versus the level, a static mesh. Test. Obviously, I have ray casting working, which is like what's going on with my mouse. But I need to get collisions working, so that's going to be a big project because collisions are like a lot of work doing that correctly. I need to do materials because right now everything is just like a texture. Everything's just treated as independent textures. So some concept of a material, I need to get that working. Obviously animated meshes for like character models. And then just from the engine standpoint, I still need to implement Metal API so I can deprecate OpenGL, or at least use the latest OpenGL version. Because right now I'm stuck to version 4.1 OpenGL because that's the latest version macOS supports. Which is really annoying because they didn't add compute shaders until like 4.3, I think. So I don't actually have full support for doing compute shaders yet either. So this little water simulation here, I'm actually doing this in a fragment shader right now. which is really stupid because I should just do this in a compute shader. But because I want this to run on Mac and I don't have Metal supported yet, I have to use a fragment shader. Which is something. I started working on 2D skeletal animations as well. Is this even going to compile? No, it's not. So this is my the beginnings of a 2D skeletal animation system, which doesn't really work too well. Yeah, so the benefits of that are, well, there's a few benefits. So in a compute shader, yeah, let me pull the fluid simulation up because it's fun to play with that while I talk. This is good because I'm taking a bit of a brain break here because I was just doing code refactor for the last few hours. Yeah, the benefits of doing the simulation in the compute shader is that when you do it through a fragment shader, well, the first obvious one is that your outputs for a fragment shader have to be like a texture, right? You ultimately write to a texture through like color information. So if I think I can bring up the debugs for these. Maybe not. You have to pull up the game for this. I can kind of demonstrate what's happening. Or actually, let me just use render doc. Let me capture some water and some lava flowing around. There wasn't even render docking. Yeah, so I can show the compute stage if I actually happen to catch one. Yeah, so like right now, so this is like one of the simulation steps, this draw call I'm looking at, and this UI is probably tiny on the live stream. But I have to store, currently I have to store the intermediate simulation data in a texture. And then in this case, I'm actually using 3 textures. And I don't actually remember the exact packing of these. But ultimately, what you're doing is you're like writing to a texture, and then you're reading from a texture in a like doing a fragment shader sort of simulation like this. Whereas if you're using a compute shader, you can kind of create your own arbitrary data types that you read from and write to. And you can write to a texture from a compute shader, obviously. But yeah, so that's one major limitation is you're like stuck with the types that you can actually write to from a compute shader. And then the second one is that obviously to run a fragment shader, you have to run the vertex shader. So you're essentially doing like this whole rasterization pipeline for every simulation step. Even though you're not actually using the vertex shader for anything other than drawing 2 triangles for which you can rasterize your pixels for. So it's just like wasteful from the graphics card standpoint because it's setting up the fragment shader like rasterization sort of stage as if like thinking it's going to actually be like rendering stuff, but I'm just using it for computation. So like this is the problem that compute shaders solved is like arbitrary data types. And there's different like the synchronization changes too when you do a compute shader. So basically it's just like for what I'm doing it would be the obvious choice for the problem. It's just that one of the limitations is that I don't have I don't have compute shader support yet on Metal, but I use my Mac pretty frequently to like develop and test on. So that's, yeah, one of my priorities soon is to get that finished. Not too much. I don't play games too often anymore. I'm really pumped for GTA 6 though. Can't wait for that to come out. Kills me that was delayed though. Should have came out like next month. But yeah, that's not Steam because Rockstar hates releasing on PC. But yeah, I don't play games too much anymore. It's kind of a shame. And yeah, that's the I guess to answer the question. Yeah, it's all hardware accelerated, that simulation. What is this stuck on? What's happening? I think my VS Code just broke. Yeah, and you can use like compute shaders for a lot of stuff. It's like another big one they use for is like particle simulations. We'll use compute shaders. A lot of like modern rendering techniques use compute for like setting up the render passes. Like, I don't know, you can really get in the weeds on this. But like pretty much every modern game with like a modern graphics pipeline heavily relies on compute now. And I can't do that with the engine yet, so I want to get that working as soon as possible. So maybe in a future stream, I can get that working. I mean, I could get it working for DirectX right now. It depends what you're doing. Yeah, I don't know. It's really nuanced. If you're like one of the downsides for using the GPU to do simulations at all is if you have like, if you need to get the information back on the CPU to do anything like game logic wise, like for instance, the water simulation in the game, I actually want that data back on the CPU every now and then to do the physics. Like you want like the water to influence objects on the CPU. So like there's a pretty significant cost actually to getting the information back from the graphics card. Because if you think of it like traditionally, like when you have just a traditional render pipeline, the communication is usually like one way. It's like the CPU sets up, I don't know, like your scene, compiles the list of draw calls, and then submits that to the graphics card, and then the graphics card will chew through all the work it has to do per frame, and then submit, and then write that out to like the frame buffer, which the monitor draws. So it's like very point A to B. So when you want the graphics card to talk back to the CPU, it can be a performance penalty because you're like forcing the CPU and GPU to sync up again, which and there are ways to mitigate the downsides of that, and it's actually easier with compute shaders to do that. Yeah, I don't really have a good explanation for how to I can tell you how I'm doing it. I'm basically doing the same thing CMake. If you know what CMake is, I don't know where to start with my explanation, how much prerequisite knowledge is needed. But if you're familiar with CMake's a really popular build system for C++. And CMake has extensions that work for VS Code. So like I think it even ships with VS Code, the CMake extensions. Or if not, it's like really easy to get them. In CMake, what CMake does is it generates a Ninja file, a .ninja, because CMake actually uses the Ninja build system So if you look that up, it's a popular C++ build system that basically takes care of caching compilation, so you're not always recompiling like the same stuff every time. So Ninja's a popular, I guess, build system. And what CMake does is it generates a Ninja file, and then Ninja actually runs the compilation. So my engine just skips CMake, and I just write the Ninja myself, because my build system does a lot of extra stuff that would be redundant if I also had CMake, because I'm like already doing the work that CMake would be doing for me. But anyway, long story short, my build system is designed so it doesn't actually need any IDE to run. So like I can just come into the command line and like manually just like call this script I have called boot, and I pass it the project name, and then it'll just compile that independent of like where you're doing that from. So then the way I have it rigged up in VS Code is I have a plugin that I wrote, which is what's like down on the bottom of my screen here, all these buttons. Like I have a build and run button. All these buttons do is just generate the command line needed to build the project with these specific like settings that you would otherwise have by just, yeah, pretty much essentially that, yeah. So that's like the general design philosophy I took when I sort of set this all up. And it's evolved over time too. I didn't come in with some master plan or anything. I've just kind of settled on this because it's working. And the plugin too is also kind of fun because I set one up for yeah, I have the plugin set up so I can just use RenderDoc just right from a hotkey as well. So like, because it's really useful to be able to do like a graphics debug. So I can just press the RenderDoc button and it launches with RenderDoc attached. And yeah, there's like, oh yeah, and then I guess to answer the questions as they come in. Yeah, I support Clang, GCC, and MSVC as compilers. So I have a button here that can switch between them. So like if I do MSVC, it compiled. It's probably hard to see on the screen because it's like low quality, but this was with MSVC running, or the compiler, and then yeah, LLVM. And this is really nice actually having access to all three of them, because each of them catch different errors. Like you can see, I have a bunch of stuff getting spammed to the console. But like GCC did not like something I'm doing in the code right now. I'm probably doing something stupid, but it's giving me a warning that the other two didn't. So yeah, that's nice to have. Yeah, it's really good to run it with all three every now and then, because you'll just catch things that you might not catch if you're running just one. Like one thing I caught just recently was that LLVM, like Clang, will allow you to have arrays that are like 0 size. So you can do like, let's see, you can do like int test 0 here. Let me actually go to the project I'm in. Just to demonstrate the power of being able to use all the compilers. So if I have like an array that's 0 size, and I go to this project, and I set it to LLVM, this will compile. So that just compiled fine. But if I go to MSVC, this won't compile, because this is an error in MSVC that Clang just lets you do because it knows to treat this as a null pointer. So that's like a bug I didn't actually catch until I ran MSVC, and I was like, oh, okay. And what age? I don't want to miss that question. So I started when I was like 9 or 10, I think. But I didn't really start like actually programming until I was probably, I don't know, 13 or 14. Because I was using Game Maker way back then. I was using Game Maker 7. Classic. The best version of Game Maker. I've been working on this engine for like a year and a half now too. On and off though, not full time. I'm trying to think what else I can show off. Yeah. Maybe I should do more streams. It's kind of fun. I'm always like afraid to show off code because like, I don't know. Some people get really opinionated about how to like actually write code. And sometimes it's easier to just not get involved with the internet and just write code. So I don't know. Maybe people will be interested. I do make some interesting decisions with the way I structure my code that I think a lot of, you know, modern C++ people wouldn't like. So I'm kind of afraid sometimes. Like one thing I kind of refuse to do in my code base is use anything from the C++ standard library. So like I have all my own, this is kind of crazy actually. So like I don't use like the standard vector or any of that stuff. I guess for two reasons. You wrote a bot to copy all my code. The GitHub's in the description, so if you want to like look at the code, you just take the GitHub. The network stuff isn't implemented yet. Let me show you. One of the goals I did with this project is I'm trying to not use libraries as like, I'm trying to use as few libraries as possible. So like for the graphic stuff, I'm obviously not using like SDL2 or something, or like, I don't know what the other popular ones are. I'm just using DirectX and like OpenGL directly, and I wrote my own interface. And I'm doing the same for like the window. So like creating the window is all just like here in the source. And I'll preface this that I did this because I just wanted to learn how it's done, not because I'm trying to be efficient with my time. So the network stuff, I've only started doing the Windows one, and I have a lot of this commented out. But it's using like the WinSocket and Windows APIs directly. And I have this turned off because it was causing me compilation issues. Yeah. So I still have to do the networking code. I don't have any networking stuff working yet. Yeah, anyway, I can continue back on my tangent about the standard library. So my biggest motivation for doing that is because every time I use the standard library, my compile times like hit the trash. And this is just like, it's just a fundamental problem with the way C++ works, I think. Vim key bindings. Yeah, right. But yeah, anyway, the standard library. Yeah, so this is like a fundamental problem with C++ is that compile times are horrible because the standard library is just super bloated as it is. So, and I realized like when you're making a like, okay, I'm just trying to think of how to frame my thoughts here. So obviously the goal of the standard library is to be as general purpose and robust as possible, right? Which is like, It's perfectly fine. I'm not anti-standard library. I think it's great. It's just that in the narrow scope of the game engine I'm working on, I know exactly what features I need from like each aspect. Like the standard vector has a lot of boilerplate, like template overloaded code that I will never use, but just by including the standard headers, like you have that code being compiled in your project, whether you like it or not. And it makes a really big difference on your compile times. And it's just like, I would rather just write the simple, like my simple vector class that I know works for like my use cases. And then my compile times are just infinitely faster. Like I can compile the entire project. Like right there, that took less than a second to compile. And this includes cleaning all the assets. So it like had to pack all the textures. It had to compile the shaders and all that. All of that took 1 second just because I'm not using the standard library. If I use the standard library, that would have taken like at least 30 seconds. And 30 seconds adds up. Like if you're doing that every time you're doing a clean build, it's like that adds up pretty quick. And the biggest motivation for me doing this was at my when I worked at the AAA game studio. The compile times there, if you did a fresh build, like no cache, anything, it could take like upwards of like 10 minutes sometimes to compile the whole project. And I was like, if there's one design thing I want to achieve with this is I do not want to be waiting 10 minutes to compile projects every time I do a clean build. So yeah, that's yeah. What's happening? There's code being pasted in here. I don't know what's going on. Why is there code here? Oh, it's getting like the formatting's all messed up on my end. I have to read this message. Yeah, just wait till you have to deal with like, I just had a nightmare the other day with packing an alignment for structs in OpenGL and DirectX being different. Okay, so I need to think, what should I work on next? I don't even know how much longer I'm going to be doing this today. There must be some low-hanging fruit I can finish off, though. Because I know I had some to-dos. Yeah. Look at the... yeah, I might as well just do a little show and tell, because it's, I don't know, it's interesting. Yeah, so as part of my graphics code, I have a custom shader language, which lets me write shaders just one time, and then this gets converted into HLSL or GLSL, depending on whether I'm using DirectX or OpenGL. But the problem with that is if you have like a uniform buffer in OpenGL, so like if I compile, actually I did compile the OpenGL. If I look at, well, this is going to look exactly the same between them. Like here's like a uniform buffer in OpenGL, and you have to specify like what your alignment layout. Oh my god, my cat is like messing with the blinds. Stop. Cat's like jingling the blinds. Yeah, this is a uniform like buffer in OpenGL, and you have, it's basically a struct, right? And it uses the std STD140 alignment rules, which is like, okay, great. You just look up the spec for that and like you get the alignment that you expect. But you do DirectX 11, where the equivalent of the uniform buffer is a C buffer, it's called, a constant buffer. This doesn't follow STD STD140. It follows a version that's close to it, but not precisely the same. So if you're going to write like a C++ struct that like mirrors this one-to-one, so you can like upload the data from one to the other, from the CPU to GPU. Here, I have a link, because I like was beating my head over this for a while until I found this. You get some weird case here, where like, here's a visualizer of this problem. So you'll have like a float, value A, or maybe I can make this a little bigger, right? So like the alignment here is what you expect, starts right here. And then you have another float, value B, right? There it is. You have a float 2, I don't know, value BC, right? Like this makes sense. This makes sense. It all works great. But if you have, let me think. If you have an array of these, like if you have one here, I'm trying to think of the exact situation. There's like a really dumb rule with this, where like float 3s are always treated as, in STD40, they're always treated as 16 bytes. But in DirectX, they're like aligned 16 bytes unless there's like certain situations where that's not true. I'm trying to think of the exact scenario I had that on before. Oh, the other weird one is if you have an array of like float 3s. So you have float 3 like array. So you have 2 of these or 3 of these. You get like each one of them gets its own 16 block. Or let's do a float 2 just to demonstrate the problem. Intuitively, you'd think they would like pack tightly, so they'd be like one right next to each other. But no, if it actually takes up a 16 block little alignment. But then if you have another float after this, it puts it at the end here instead of putting it like down here like you would expect. Because in STD140, A would be on the next line. You would see A at address 48 rather than 40. This is me ranting about alignment rules with GLSL. So anyway, basically, I had to write code that could mirror the alignment rules of HLSL and GLSL, and then implement my own padding in the struct. So like if I look in some of the structs here, maybe if I go to Vitality, the other game, has more intense graphics code. Let me compile it so we get the most recent. Let's see. If I go to the output code that gets generated here, I think. Oh, none of these have padding. Wow, surprising. Anyway, I basically generate the structs in the build time, and if the padding's wrong, it has to insert like empty bytes in here, which I don't have an example of right now, so I guess maybe I can't show that off, but yeah, it was a nightmare. And the problem is like it doesn't even error when you like write the wrong data, because obviously it doesn't, like when you upload the uniform data from the CPU to the GPU, you're just sending over like raw bytes. So it doesn't know that the alignment's wrong if you're just sending over like a buffer of just bytes. So it doesn't fail in an obvious way if you have the alignment incorrect. So it's like I was having these problems where I would add like an extra uniform field to one of these structs, and then like I just wouldn't have the data in the shader. And I'm like, what is going on? It works fine in OpenGL. But yeah, that was a nightmare. So long story short, just use a game engine. Don't make your own. Yeah. These little probes do look like light probes, don't they? I should do a global illumination shader. Do like light probes. You can go to different levels too. Let's get a nice snowy level. PS2 era. All right, back to the low-hanging fruit. I can be productive for at least another little bit here, because unfortunately I'm busy most of the week. So I didn't choose these graphics. This is just what debug graphics looks like. This is a really old level file from when I was like 14, and I just ported it to work in the engine as a fun little test map. My main focus right now is just getting the graphics features actually working. So the level itself is just temporary. I do kind of like the retro aesthetic though, I'll be honest. All right, let's see. Trying to think what I can work on. Trying to think of things that are easy to work on within like 30 minutes to an hour. Oh yeah, these things. This is just rendering it to like the screen. Like a 2D coordinate on the screen. So it's taking like the 3D coordinate and then mapping it to screen coordinates, just so it's like always in the right spot. I actually have a text editor that I wrote. Check this out. Check out my text editor. It's not really a text editor. This is my UI library. Forgot about this. Scroll bars, check out these scroll bars. It's with just whatever graphics backend I have. It might trigger me. Will it trigger me? It's not too hard. It just depends what you, I don't know. Depends what, image drag and scroll panel, yeah. This is my text library. How would I go about writing an efficient text library? I don't even know. Probably arena based, yeah, so you're not having constant like memory reallocations. Yeah, thanks for stopping by. I appreciate the chat, it's fun. Image scroll panel. Oh yeah, so the FPS question. Sorry, I'm getting scatterbrained. I mean, the trick to FPS really is just like you minimize the amount of state changes for the graphics card. You minimize the data throughput. So like the biggest bottleneck for frame rates in the modern day isn't actually like rendering triangles. It's the data like throughput between either to the CPU and to the GPU, or from even just like getting stuff out of GPU memory. Like if you're like, I don't know, just accessing memory is really slow. That's like the slowest part of pretty much anything nowadays. So if you're trying to optimize FPS, it's like depends which angle you're looking at. And it depends where your bottlenecks are too. Like, yeah, like memory allocation is the worst. And that's another reason that I kind of just wrote my own like baby version of the standard library for my various like vector and stuff. It's because like I know exactly when things are getting allocated. Because like every time you call to malloc, you're basically waiting for the operating system to like find you memory and then return it. Like return you a pointer to that memory. So it's like your program has to stall until the operating system can find you memory. And that can actually like take a not insignificant amount of time. So if you're constantly like reallocating memory, you're going to spend a lot of time just hanging on malloc calls. But then like even that, the deeper you get into it, it's like, okay, memory allocations aside, it's like, what's your memory access patterns? Because like the speed at which you can access memory is dependent on like the concept of cache. So if you're not familiar with like how cache works, like that has a big influence. But yeah, like generally the biggest bottleneck in any application nowadays is just memory bandwidth or like cache misses. So there's not like an easy answer to that, I guess. Because like you can have a game has low FPS for a million different reasons. And it's like it could just be simple stuff to fix. There's also like a lot of complicated stuff too. Like especially in game, like makes me think of game engines nowadays. Like you might hear like the entity component system used a lot. The concept of ECS, entity component system. And like the big benefit of an entity component system is that you have good like data locality with your entities. So if you basically just have a lot of entities and it's just spatially just allocated in a friendly way for cache, for computer cache, which is again the biggest bottleneck with like CPU performance in the modern day. And there's like a lot of tricks the CPU actually does like internally to try and like intelligently do like handle cache. Like you have like cache prediction that the CPU does without you even like having to do anything. Yeah, and that's data oriented design is big on that, because it's like I could go on for a while, but yeah, it's interesting. So yeah, like if you're gonna do efficient text renderer, like an arena is great because you can just allocate this big arena at startup, some big like virtual, I don't know, page or something, and then like commit as you go without having to like reallocate new memory somewhere else and like do mem copies to, keep pointers from invalidating. It's kind of like using it as a stack, right? It's like you just kind of create your own stack allocator. Okay, so let's go to the graphics code. I have a lot of to-dos in here. Getting so distracted. I'm just like clicking around. Let's see. Not build. Core, Manta, backend, graphics. I don't do multi-threading really. At least not in the engine currently. I do have like the ability to do multi-threading, Oh, I never even showed off my voxel project. Yeah, that's another classic one. Oh, it doesn't work. Of course it doesn't. Hold up, I have to fix this. Here's my little Minecraft clone. Draw. Why isn't it like this? What is it about? One second. Why isn't this working? Do I not use GFX? What's happening? I don't understand what this compile error is. Oh, it's not even a real error. Of course it's not. This is the graphics code I changed earlier that I need to upgrade. I did see that actually. No matching function call. What is happening? What is going on? This candidate ignored. Could not match against voxel vertex. What is going on? Do I need to dereference this? Yeah, there we go. Yeah, here's my Minecraft clone. Forgot to show off my Minecraft clone. My Minecraft clone where you can do nothing but fly around. How do I reset the shadows? I forget. Oh, here we go. Minecraft clone with vertex shadows. But yeah, I did see the pirate software thing. It's not. I don't even think the array, the giant array of the giant array of dialogue was a bad idea. Like, I mean, like the problem is he wasn't even using like enums or anything to actually like index the array. So it's like he just had to memorize this giant array and he was indexing it with just like numbers. So he's had these magic numbers everywhere. And God forbid you add dialogue to the beginning of the array. Now it's like everything has to be shifted manually. Whereas if you just use like an enum table, you can just insert an enum to the top of the table and everything gets adjusted automatically. Because like the enum IDs are like picked by the compiler, right? Sequentially, obviously. Because like I use tables for stuff all the time. Like in fact, my whole asset system is just a giant set of tables with IDs. Like if I go into my code, where are we? If I go into the Vitality code, the game with the water simulation, it's like output. Like my whole asset system. So here are like the sprites. If I go here, it's like, where are the sprites in here? I have these giant tables of like the sprite data. Now I generate these tables automatically every time the build runs, or every time it needs to rebuild the, I guess, the assets. But like when I'm actually accessing the sprites in game code, I use enums. It's just funny that he didn't use enums. Yeah, I do a lot of meta programming. It's good and bad. I'm kind of mixed on like, so obviously the engine relies on generated C++ code that then gets compiled into like the final executable, which is different from how a lot of game engines work. Like a common pattern for game engine design is you have like your engine library, which is all the stuff you use. You compile that as like a DLL, and then your game runtime would be a separate project that statically links to that, or even dynamically links if you have like hot reloading for things. And then your game runtime would be like its own executable, but your game code in this design philosophy, your game runtime code would just fully read all the data from a file. So you would never actually have like hard-coded game data as part of your runtime executable, because that gets loaded in, I guess, when the runtime runs, and that's why it's called like a runner, right? I decided I didn't want to do that just because, I don't know, I just didn't want to do that. So I just generate a lot of code that just gets compiled directly into the game. But that's also because I don't have a scripting language either, at least not yet. Because a lot of game engines, they have a scripting language which kind of hooks into engine features. Yeah, exactly. Yeah, if you compile the data into your source, it's going to be significantly faster. And the compiler can like optimize it like pretty damn well too, if you have like, I don't know, the highest optimization flags on. Because if the executable knows everything that it has, it's like the compiler can be a lot more aggressive with like inlining stuff or reordering stuff. Yeah, it's VS Code. I have a custom theme applied to it, so it looks a little different. Let's see. Yeah, I'm trying to think of what's next. What do I do next? Yeah. It's such an iterative process too. Like I'm just constantly going back and refining things. So like the code you see here is probably like not even the... yeah, the audio does use threads. Yeah, the audio is actually quite a system. Yeah, so it's kind of, yeah, the audio is its own system. That was a that was a project too. Yeah, so the audio, I support different, I can open up the little example project actually. Where is it? Systems. I don't know if you can hear this. I have music playing, but I have different effects. I have like reverb. It's probably not coming up too well. I have like low pass cutoff, volume obviously. forget which key it is to change this. Yeah, stop that. It's killing my ears. But yeah, for the audio backend is actually really simple for each platform. Like on Windows, I just use Wasapi, Windows Audio API or something. And Core Audio is, I believe this is Mac, and ALSA is the one I use on Linux. But anyway, these all work the same way. It's just like this is how it talks to the operating system and the audio drivers. But the actual like meat of the audio system, all it does is it takes in a, where is it? Can't even find the code I'm looking for. It basically just gives it like, I generate the samples, like the actual audio sound samples at the frequency that, like my playback frequency, which I think is like 100 hertz. But I only write the code to do that in one spot, and that's up here in the audio module. So like I have a function in here for like mixing audio somewhere. Yeah, here's my audio mixer code. And this runs basically in the background on a separate thread. And what it does is it just loops over basically all the audio channels that I have. And obviously it performs logic for the different like audio effects like reverb and the low pass filter. But in the end of the day, it just submits the data to these backend APIs and then it sends it to the driver. So yeah, it's like you basically create a buffer that contains the samples, which is just, like in this case, I think I use a unsigned 16-bit integer for the samples. You can use floating point samples too. I guess you get higher quality sound, but it's obviously more expensive to work with floating points. But it's like a buffer of unsigned ints, or signed ints, I guess, because you have negative amplitude for a wave. And it sends that. So that's how audio is done. And it's like, I will say, it's almost impossible to find good audio code online. So this is another reason I wanted to make my GitHub like public, because it's so hard to find this stuff. So if anyone else is ever having problems with this, they can maybe look at mine and see how I'm doing it. If I'm even doing it the correct way, who knows? But yeah, I can support, like if I go to Vitality here. I do have a glitch with it. I know there's a, I haven't, my multi-threading isn't perfect because there's a, every now and then I get like a race condition where it causes problems. So if I go to debug audio here, it's kind of hard to see actually, if I make it night. Still kind of hard to see. It's probably tiny on the live stream. But like each of these little debug panels is like a different sound effect that's playing. If I add water, you can see like I have a ton of splash sound effects that play. And if I go underwater, it applies a reverb and a low pass filter. I'm actually in a 1440p monitor. I forget what size. Might be a 32. I know I made sure to get, or maybe it's a 27 inch. Because I have two of the same exact ones. I made sure to get two of the same ones. Because for a while I was supporting two monitors that were different sizes. And it was really annoying. Yeah, I'm really proud of the water physics. It's cool because it supports like actual like waves. It's not perfect because it's kind of a low resolution simulation. It has water pressure as well. Like if you have a really deep lake like this, and I open up a little hole here, like sprays in there. It's like an interview question. It's like a design and architecture question. I don't know. It depends on the game. Depends on the game. Yeah, they probably would, yeah. It's the kind of question they would ask. It's like the classic design systems question. I'm at the point where I've stopped programming. I'm just like playing with the game, playing with the code. My brain's a little shot, I'll be honest. It's getting late. Well, it's not getting too late, but... yeah, I don't know how well it'd work in 3D. Yeah, so the way the water works, the simulation, is it's not... it doesn't use particles. Like a lot of fluid simulations you'll see use particles. And you'll have the particles actually like... You'll have rules for how they interact with each other. And then you'll have like spatial partitioning to make the interactions more local, obviously for performance. But this doesn't use particles directly, so it's actually simulated like a cellular automata kind of. So like each cell or each block has like I think 4x4, so 16 cells for which a fluid can exist in. And there's like 2 passes of the simulation that basically simulate what the next frame will be based on I guess the current state of the cell and its neighbors. Is like the highest level. So the problem if you did a 3D simulation like this is you're obviously adding another whole dimension of data you'll need to do to keep track of for the simulation to actually like apply those rules. Whereas if you have particles, it's as easy as just adding an extra dimension to the particle. But the amount of data that you're actually using for the simulation is roughly the same. I mean, obviously you have more particles to fill up a 3D volume. But I would need like a 3D buffer. And then you simulate every cell in the buffer every frame, which just doesn't scale in the 3 dimensions, unfortunately. I just forget how fun it is to play with the water. Yeah, the cool thing is it's a really efficient simulation too. So I can have like really big volumes of water being simulated. Well, the reason why is I don't have the time. I'm still working on it. It's a time-consuming process. And making my own engine probably isn't the most efficient way of doing it either. So I just haven't. I'm still working on it, I guess. That's the answer. Maybe someday it'll get finished. I don't know. You need a lot more than a water simulation to be a game on Steam, though. Because programmers might find it interesting, but I don't think the everyday person will be as intrigued. Maybe I'm wrong, though. Who knows? Just add workshop, yeah. I'll add mod support. But yeah, I have this little snowflake thing. I want to add snow as well. Here's my snowflake test. This is final. It's like, why make the game when they can make it for you? Mod support. It's not even a bad idea. Yeah, I think my next step should be actually do some rendering, some nice lighting. Getting kind of bored of looking at this crazy scene of spheres. I'm really proud of my sphere generation code, though. I've showed this off a few times today, but I'm still going to look at it again. Procedural spheres. Look at this. You can change the resolution. Procedural. Yeah. I don't even know what to do anymore. In this project, I did start to write the bare bones framework for a deferred renderer, but I don't actually use this for anything yet. So I might get to that soon. Is this actually working? I don't even know if this is doing anything. Do I use this? No, I'm not even using this. Yeah, it's all single threaded for now. Well, the audio is on a separate thread, but the game loop is on the main thread. I'm still not sure what I want to do with multi-threading, because yeah, it just gets really complicated. Once you add multi-threading, everything just gets really complicated. Yeah, I'll need to get the Steam API in here too. That's a good point. It should be easy. You should probably just link to it, right? And just include the header file. I wonder how it works. Do you need like an app ID or something to actually like talk to Steam? Because I assume you need to like register your app. It has to communicate with their server somehow. I don't know how any of that works. I'll have to look that up. Sounds a little complicated. Let's see. Yeah. Lock-free algorithms are the best because if they're designed right, you don't have to worry about any race conditions or stuff like that, because they shouldn't have any problems with those because they're lock-free. But you ultimately mess that up and you end up with impossible to debug problems. I do have a threading class in here, or I guess module. What do I have in it though? I don't even remember. I can do the basic stuff. Oh, I have a concurrent queue implemented, which is a lock. This one uses mutex and a condition. I forget what I even use this for. I'm not even confident it works. Here, while we're at it, I'm gonna do some preemptive work. This will be the last thing I do tonight, probably. Let's get some preemptive compute shader dispatch code into my graphics backend. This will force me to actually take deprecating OpenGL seriously. So we have so I need to look up so dispatch takes 3 uints. Group count X, Y, Z. Here's my shader dispatch function, compute dispatch. And then I will need to implement this in DirectX backend. I guess I can do the OpenGL, I just need to deprecate the old version. Awesome. Yeah, you should stream. It's fun. See, I'm never a streamer, you know. It's kind of fun. I might do this more often. When I'm doing interesting stuff, I won't spam streams too much. Why is this not working? GFX core. Classic. All right, let's see. Where's my shader bind code? I should move that stuff down here, actually. Or I should move this up there, I suppose. I'm gonna move my shader code down to the bottom of this class. I guess this does take a resource. I have to look up, how do I actually bind a compute shader? So I do this up here somewhere. Let's see. So set shader resource, and then dispatch. Why do I have like mix of indentation and tabs? So set shader, I do this here. So I don't actually have a compute shader implemented in here yet. So that's in there. Compute shader. Hey, how's it going? Welcome to the stream. The tail end of the stream, unfortunately, because I'm probably gonna leave soon. I'm getting pretty hungry. But I'm trying to grind out one last little feature here. I don't even know how I'm gonna work this though. Maybe this isn't dispatch. Should just be like RB underscore dispatch. Yeah, I've been at this for a while this afternoon, this evening. Working on a bunch of random graphics related code. And looks pretty crazy at the moment. But every little piece here tells a story. Alright, so we got that done. Now, how do you dispatch a compute shader in OpenGL? Well, you can do indirect. Alright, I will leave this as a to-do. And this is also a to-do. Yeah, you gotta be careful, man. It's a tough world out there with AI. You just have to write more code. Write code. I almost fall into that trap too sometimes, I'll be honest. Cause it's so easy. It's so satisfying when the AI actually like gets stuff right. The problem is that like if you rely on it too much, obviously you kind of, yeah, you just, I don't know. You start to rely on it too much. What else is there to say? Yeah, I don't use Copilot. I refuse to have AI integrated in my editor. The only, and I kind of refuse to let AI generate code for me either. I would lie if I said I didn't use it sometimes, because sometimes it like is fast to just like get the AI to spit some stuff out. Yeah, I agree. I agree fully. and like, I don't know. I like programming because it's like, I kind of like the artwork of it as well. Like, I don't know. Maybe I'm just old school for saying that, but I find the act of programming to be really fun. And like there isn't a right answer a lot of times. It's kind of like up to you to sort of decide how you're kind of sculpting your program and how you want it to behave. And I find that process fun. That's just why I code. So I just don't see the appeal of using AI unless I'm trying to actually like avoid coding myself, which does happen sometimes. Like there is some stuff I don't want to code, and AI is actually pretty great for that. But just personally, I don't know. I'm not too interested in it. Okay, so this needs to be... taking a shader maybe. I'm sure your skill isn't gone. It's probably a bit, a bit extreme. Because like even using Copilot, at least you're exposed to the code, like you're seeing it. Obviously, it's different than writing it yourself, but it's not like you just went cold turkey. So I don't know. I don't like how I'm doing this at all. What am I doing here? Why is there this weird indirection layer with my shader code? Ooh, maybe I should just change this. I do not like this. Shader entry. Alright, well, I'll follow the pattern for now, but I will refactor this because I do not like that very much. State is not a member of GFX. What are you talking about? What are you talking about? How is it not a part of... Why is that even inlined? This does not need to be... The reason you want that is because, say you have like yeah, the flag is important because you want to be able to compile the game without any graphics sometimes. Like, say for instance you're a server for a game that's just running on a virtual machine, right? Like a headless server. And you wouldn't run any graphics code, and you wouldn't want to link to any like graphics library because you're never going to submit graphics code. But I still want, you still might use these functions around your code base. Like, yeah, I don't know how else to explain it. It lets me run the game without having any graphics running. So like I can run this in headless mode, which doesn't work obviously for some reason. I don't know, I'm probably missing something in here, but oh, I'm in the wrong backend. Yeah, I need to fix some compile issues. But basically it lets you run without linking to a graphics library, which is important if you're like a server or something. I should just fix those issues right now, actually. What's the problem? I think I've changed some of my files, because this is in the null backend, so I don't have any of these anymore, of course. Let's see. Yeah, I haven't updated this in a while. So I need this function at the bottom. And I need the draw function. Need this one. That just does nothing. And failed to pre-process shaders. Invalid preprocessor command version. Is that just a fake error? Now what? These messages are like impossible to parse. All right, here we go. Here's the error. This is different. Yeah. Oh, I need all the instance buffer code in here as well. Let's get the shader stuff down here. And we need to do instance buffer code down here. Oh, I'm gonna cut that. Alright, almost close. Missing and a semicolon. Alright, here we go. Renders without the backend. So there's no graphics anymore, which is nice. Yeah, and you can, yeah, certainly use it for that too. I'm glad I fixed that right away. Let's see. CS is, let's see. Oh, I'm surprised I did the boilerplate for that. Yeah. It always feels weird to have a server running GPU code, but now in the day of GPU compute, it's more common. I'm gonna put the compute up here. This is exciting. Compute shaders. So we want to compile, strip the actually I don't have why does this keep changing? Unfortunately, I don't actually have compute shaders functional in terms of getting valid HLSL for those, but we can do all the boilerplate first. So size CS stripped, create compute shader, takes that, and compute shader. And then up here, do this. Should do all the other shader stages as well. Compute. Okay, so stripped. VS Code stripped. And then doesn't like this. It's not in DirectX mode. Yeah, it's not gonna like that. What's the problem? Let's see a size. All right, yeah. Now I know this wasn't gonna work because so let's see. Fortunately, I don't have that working, so that's gonna have to come another day. But we have the pipe work in place. Let's do a particle stress test again, just for fun. Let's turn off all these debug things. Let's do 5 million particles. I'm rendering 5 million particles, all simulated and rotating towards the camera at 175 frames a second in 1440p. Freeze them in place. If I do 50 million. Oh, it doesn't like 50 million. I'm still getting 20 FPS doing 50 million particles. It's actually crazy. I bet if I made them not transparent, like if I turned off depth, like blending, it would be a lot faster too. This looks like just crazy. It looks like cobwebs in Minecraft. When you get stuck in the webs. There we go. A much more manageable 50,000 particles. I'm really inspired to do a particle simulation system now. Particle system. I'm inspired by these billboard quads. I can't even tell if it's working correctly. It's like, I don't know if it should be rotating like that. I think it's fine. It almost feels like the math is wrong slightly. It's like hard to... It's like the vectors I'm using to rotate the quad. Point towards like the view rather than the projected viewpoint of the quad, if that makes any sense. This is crazy. Let's get that red fog in here. The blood fog. Or, well, my microphone's acting weird. I think we just lost sound. I just lost sound. It just happened. I can't hear anymore. Where did my sound go? I lost my relaxing background music. Oh, there it is. Okay, we're good. My microphone did like some weird, crazy thing in my headphones. I have like a driver issue or something with my microphone where like every few hours it'll just start spazzing out. But I think I'm going to end the stream today. I've been going for like 6.5 hours and I need to eat. It's getting like 9 o'clock at night. So I appreciate everyone stopping by. It was a good time. I'll try and stream again more frequently. I don't have a schedule yet though, because I just don't know when good times are, but hopefully I see you guys again soon. It's a good time. But yeah, thanks for stopping by. See you guys. As I frantically stop to end the live stream.